How are you doing? Can you just let me know if audio, video, everything is fine? Is there any echo? Can you just let me know if there is any echo? So we will see compiler design today. I mean compiler design marathon part 2. There we will be covering bottom-up parsers. Okay. So before I start, can you just tell me if there is any echo? If there is any echo in voice? Okay. If there is no echo, then we will just start. Just let me know. Okay. So as you guys know that we will be covering bottom-up parsers, right? So now in this particular session, we will be covering bottom-up parsers. Okay. So like before I start, I just like to know if there is any echo. Okay. If there is no echo, then we will just start. Everything is fine, right? Audio, video, everything is fine. Okay. So once you tell me that everything is fine, then we will be just starting. Okay. So I think everything is fine. Okay. Okay, great. So everything is clear. Now let's just get started. Great. So this is basically bottom-up parsers. Okay. So I mean, in this session, we will be studying bottom-up parsers. Okay. Now we have already seen what are top-down parsers in the part 1. Okay, so you can just Google it out. I mean, you can search on the YouTube, or maybe I can just put a link here also. So let me just put that link here. Okay, so that you can just if you have not seen part 1, then you can just see that part 1 also. Okay, so if you search like this, let me just put the screenshot here. If you search like this, then you will be seeing part 1. Okay, is this fine to everyone? Let me know. Now in this part 1, we have already discussed few of the things. Now we are going to discuss next few of the things, which means here we have discussed top down parsers. Now we will be discussing bottom up parsers, right? So we will be discussing what are the bottom up parsers and all type of bottom up parsers: LR0, SLR1, LALR1 and LR1. So these are the 4 type of bottom up parsers, and there has been many gate PYQs that they have asked from these parsers. Okay, there has been many gate PYQs. So we will be solving, you can say, all of them. Okay, I mean most of them in the sense that if there are 1-2 PYQ or maybe 3-4 PYQ, if we are not solving, it means that is extremely easy. Okay, it might be the only reason that we are not solving that here. Okay, so if it is related to bottom up parser, then we will be solving those PYQs, all of them. Okay, so that you get more confidence. So we will be solving many PYQs here. Now before I start bottom up parsers, let me just tell you what are the parsers. Okay, for example, what is parsing? Although we have covered these things in the part 1, but still let me just quickly remind you. Let's suppose you have some grammar. Okay, let's suppose this is your grammar, something like that, right? B and A gives C. Okay, and let's suppose you want to parse, or you want to check whether this string, okay, this string in grammar or not. Okay, or maybe you can say in the language of grammar or not. Suppose you want to check this, right? So this checking, okay, this checking is called, this particular checking that we are doing, this particular checking is called parsing. This is called parsing, right? Now there are 2 ways, in the sense that you can either start from start symbol and then you can go to this CAB. Okay, I mean you can go to the string. There are 2 ways. This is called top down. If you are starting from the start symbol, let me just tell you. See, if you are starting from start symbol and going to down, that is called top down. For example, if you are starting from S and then you are going to down, right? This is called CAB. Let's suppose you are going to get this CAB. This is called top down. Okay, top down parsing, right? Is this okay to everyone? I think this particular definition is known to everyone. Okay, and if we start from CAB, let's suppose if we start from CAB and if we move to S, this is called bottom up. Okay, this is called bottom up. Now we will see how to do this bottom up today. So let me just directly start. Okay, let me directly start bottom up parsing. But before that, let me first tell you one definition, which is called rightmost derivation. Suppose this grammar is given to you. Given this grammar, you want to derive this string. which is ABA. Suppose given this grammar, you want to drive ABA, but the condition here is that you will be driving always rightmost, let's suppose, which means if you have two symbols to choose from, then you will be choosing the rightmost one here. Okay, this is the condition that we have. So here, from here, you will be, if you have to choose the rightmost one, then which one will you be choosing? Will you be choosing A or you will be choosing B? Just tell me. Will you be choosing A or B? You will be definitely choosing B, isn't it? So basically you will say, if you choose B, it will be A, B, A, and then you will be choosing A, and then this is basically A, B, A, right? I mean, finally you got this particular string, which was desired one. So this is called rightmost derivation. Okay, you might have heard about these things. This is called rightmost derivation, RMD. Okay, RMD means rightmost derivation. Is this fine to everyone? Okay, great. This is one way to do it. You can also do leftmost derivation, in the sense that you can start from S and then this is ABA, and instead of exploring this B, you can explore this small a, and then you can say, since you want to explore this small a, so it will be after that it will be basically A, capital B, A, and then you will be exploring this capital B or reducing using this capital B. So it will be like this, right? So finally you can get this also using this only using something called LMD, leftmost derivation. Okay, so either you can do RMD or you can do LMD. It is your choice. But here we are basically seeing one parser which is called bottom-up parser, and bottom-up parsers somehow mimic this RMD. We will see how. Okay, so bottom-up parsers somehow mimic this RMD. See, one thing is for sure, that bottom-up parser cannot start from a start symbol. Tell me, can they start from a start symbol? Can the bottom-up parsers start from a start symbol? See, if you're talking about top-down start from a start symbol, right? And reach to the string. Can bottom-up parser start from a start symbol? No, right? No. Bottom-up parsers cannot start from start symbols, but I will just tell you that bottom-up parsers somehow mimic this RMD. Although they cannot start from a start symbol, still they somehow mimic this RMD, which is called rightmost derivation. Okay. Now, coming to the bottom-up parsers, that what is the working of bottom-up parsers? Okay. Let's just see. Suppose, again, you want to parse this ABA. See, there are two ways to do it. One is that you start from the start symbol, okay, and then you do A, B, small a, and then you say that, okay, this is going to A, I mean this will producing A, this will be producing B, and finally you got ABA as an string. AB as an string, right? So this is one thing, which is basically this ABA, whatever you have got as an string, which is basically, you will say, a top-down way to do it. Okay, a top-down way to do it. Top-down parsers. Is this fine to everyone? Now you can do, or you can derive the same string using something called bottom-up parser. How? Let's just see. Okay, this was top-down way to do it, but you can do it using bottom-up parser also. How? Let me just tell you. See, suppose you start from ABA, which is the string itself. Okay, and then you say, okay, I see this A. Using this A, I will be going to capital A, which means I will be reducing to capital A. Okay, you start from left to right only. Okay, and using this small a, I will be going to capital A. Is this fine to everyone? Is this fine? Now using this capital B, okay, you can go to using this small b, you can go to capital B. And then using this ABA, you can finally reach to capital S. Okay, you can finally reach to capital S. Is this fine to everyone? Which means what I'm trying to say here is that you started from ABA and then ultimately you are reaching to S, right? See, although they looks like this, okay, I mean they looks like a same one, but the working was different. It was top down and it is bottom up, right? So this is what we will study today. Okay, this is bottom up parsing. Let me just know if this is fine to everyone. Okay, let me just know if that is fine to everyone, that what is top down and what is bottom up. Is this fine? Little bit idea you might have got it, right? Obviously we will see more idea, but little bit idea you might have got it, that what is top down, what is bottom up. Okay, great. Just give me a heads up that this is fine. Okay, then we will move to the next thing. Now you notice one thing, that if I just ask you here that what are the sequence of steps that have been performed for this bottom up. Okay, let's just understand this bottom up little bit more, because this is something which we will study today, right? So let's just try to understand this bottom up little bit more. So here, if I ask you what are the sequence of steps that you did, okay, what are the sequence of steps we performed? Okay, what are the sequence of steps we performed? You will say that or sequence of reduction, it is called reduction actually. You will say that, okay, the very first reduction we have done is this. We have reduced this small a to capital A, right? This was the very first. This, let me just number here itself. It was the very first, and then this was the second, and this whole thing, you can say this was the third, right? This was the third. Okay, or let me use a different color here. So this was the first one. Sorry, different color is this one. Okay, yeah, this was the first one, this is the second one, and this is the third one. Is this fine to everyone? These are, see, I first reduced to this, and then I reduced to this, and then I reduced all of this 3 to S, right? So this is the sequence of called reductions. Okay, these are the 3 reductions we have performed here. Great. So I'm very impressed to see one one line that one of the student had just commented, which is very relevant line. So he is saying that these are the sequence of steps. Okay, so he has just written out the sequence of steps. So let me just do one thing. Let me just zoom it out. Okay, and I want to emphasize actually on one thing, so that you can understand things very clearly. So let me just zoom it out. So first what we did, we have basically started with ABA, and then finally we have got a capital A BA, right? From ABA, after this first reduction, we have got capital A BA. Then after the second reduction, we have got capital A, capital B and A. And then finally we got S, right? So this is the sequence of steps that we did, isn't it? Let me know if that is fine to everyone. Okay. So he is saying I have studied from you. Okay. So Swanshu, are you enrolled student? So he has studied from Go Classes lectures, I think, but that's really nice to see. Okay. So are you enrolled students? Now see here, these are the sequence of steps, right? Now I would just want you to know one thing. See, we have already done something called as RMD. Okay. Let me do one thing here. Let me just put side by side these 2 slides, which are going to be very interesting slides. Okay, so RMD slide and bottom up parser slide, basically. Okay, this is what we have done in RMD, right? Now this is the slide number 1, you can say. Okay, this is the slide number 1. Now let me put the next slide, which is slide number 2, and where we will be doing we will be seeing that how does the bottom up parser has performed, right? How bottom up parser has performed. So let's just put this slide also, right? Okay, on the same page I want to put both the slides. Now you just notice one thing here, that bottom up parser have performed these sequence of steps, right? These sequence of steps, which are let me just again zoom it out, these one. Okay, so basically or maybe I can just write it here. So these are the ones, right? I'm not able to zoom it, but I can just rewrite it, right? Basically you have started from ABA, then you moved to capital A BA, then you moved to capital A capital B A, then you moved to capital S, right? You just notice here that in RMD isn't we doing the same thing? Aren't we doing the same thing? So see here, if you just check RMD from the reverse, okay, ABA to this, and then this to this, right? And then to capital S. So this whole thing is RMD, but isn't it isn't this whatever we are doing, isn't this is RMD in reverse? See, this is RMD, I agree. But do you also agree that this is RMD in reverse? Do you also agree with this? Do you also agree with this? See, see, the point here is that we have our rightmost derivation, right? But we also have rightmost derivation in reverse if we do bottom up parsing. So from this we conclude, okay, that bottom up parsing and RMD in reverse is exactly same thing. I mean, bottom up parsing just does RMD only, but obviously it has to do in reverse. I mean, RMD has to start from a start symbol and it cannot start from a start symbol. That is obvious, right? Because it is bottom up. So since it is bottom up, it has to be in reverse. I mean, it has to start from this and then it goes to this, then it goes to this, then it goes to this. Okay, so we have just seen that bottom up parser is exactly same as RMD in reverse, and this is one this is one of the result that that we should be knowing, because based on this result there has been many, I think there has been many, in the sense 3 to 4 PYQs, gate PYQs, just based on this result. Now if you have studied this compiler design already, then tell me, have you understood this particular result or this particular relation between RMD and bottom up parsing before? See, you might be knowing, most of the students just mug up this. Okay, most of the students just mug up this, that this is the bottom up parsing is RMD in reverse. Okay, just most of the students just mug up this. Most of the student, if you have understood, that is fine, but most of the student do not know that why that is the case. You just have to take a simple example. See, this is RMD. Just take the simple example of bottom up parsing. You will realize that bottom up parsing is nothing but RMD in reverse. So you do not need to mug up this, right? You do not need to mug up this. Now you have understood this, right? So I hope that this picture is clear to everyone, that bottom up parsing is nothing but RMD in reverse. Okay. By the way, how many of you have just mug up this earlier? Let me know. There is, don't be shy about it. If you have, if you have just by hearted this, it is okay. But have you understood it now? Have you understood it now? That bottom up parsing and RMD in reverse is same. There has been many students that has already by hearted it. That is fine. Okay, if you have by hearted, it is also fine. But now I'm asking, have you understood that RMD in reverse and bottom up parsing is same? Great. Okay. Right. Now, now let's do one thing. Let's solve some gate PYQ. There has been very recent, okay, gate PYQ, and what they're asking is very simple. Which one of the following kind of derivation is done by LR parser? LR parser is nothing but bottom up parsers. Okay. Bottom up parsers. And the reason why it is called LR, because we are going left to right and we are doing R means reverse of RMD. Actually, reverse of RMD. From this R itself, you know that it is reverse of RMD. So, does this do leftmost or leftmost in reverse, or rightmost or RMD or rightmost in reverse? Tell me, what is the correct answer here? It is easy question and D is correct answer, right? D is correct answer here. Okay. This L means we go left to right. This L means we go left to right. From left we go. Okay. But we do reverse RMD because we don't have any choice. We have to do reverse RMD. Let's see this question which has been asked in GATE, and then UGC NET has copied it later on. Okay. So which one of the following derivation does a top-down parser perform? So which one top-down parser perform? Tell me. Which one top-down parser perform? Top-down parser basically do what? Let's suppose this is capital A. I think we have done the top-down parser also. See here. So basically it will be basically performing if you notice, leftmost only, right? It is very easy to understand, because first you do this, and then it is going to the left, and it is saying that okay, now I want to produce a, then b, and then small a. So top down parser perform leftmost derivation, okay, and not in reverse, just a leftmost derivation. It doesn't have to be doing reverse, okay. It is not in reverse, leftmost not in reverse, it is just like leftmost only. So that is why a is the correct answer, because it will anyway start from a start symbol, okay. So one of the student is asking that in bottom up, why it can't be leftmost in reverse? See, we have just seen it, right? We have just seen it that RMD, okay, RMD, which means, so just a second. So see here, we have just seen that RMD and bottom up parsers are actually same. It is just that bottom up parser does RMD in reverse, right? Because this is the working. This is how it will work. You will start from a small b, and a small a, right? So you will start from some string, and then you notice that if you are going left to right, then if you are reducing it, then you are reducing it automatically. Automatically, it is RMD in reverse. Okay, you are starting with this, then you are going to this, right? And then you are going to this, then you are going to start symbol. Then if you see from the start symbol, then it is basically rightmost derivation only, okay, rightmost derivation only. It is like you are doing this, then you are exploring this b, okay, but in reverse. Using this example, we can just see this. So I think ISRO has also tried to copy the same thing, that there's a top down parser which does what, RMD or RMD in reverse, or leftmost in reverse. So I think C is correct answer here, okay, C is correct answer here. Now let's just do this interesting question which has been asked in GATE 2020. What they're saying, consider the following grammar. This is one of the a production in the grammar, or two productions, and this is another production. Now they're saying the number of reduction steps. Reduction means that, let's suppose, see, this string is given triple A D triple B, right? So it is obvious that D will be here. Let me just explain you what is the reduction first, okay, and this will be generated. So basically D, this B can only generate one B, right? So it has to be capital B, capital B, capital B, and then this ASB, right? This is ASB, this is ASB, this is ASB is A. Okay, so maybe it will be going like this, right? Okay, I will be just reducing it or to the start symbol. So what is the reduction? Let me first tell you what is the reduction. Reduction is that, let's suppose you are starting from okay, in this particular example we will be reducing it after some symbol, but let me just give you the example where we are reducing it very early. For example, this, right? Reduction is this, okay. Reduction means that you are going from small to capital, okay. You are going to non-terminal, that is called reduction. So this is one reduction. So if I just ask you how many reductions we have performed here, this is one reduction, this is another reduction. So can you tell me what are the total number of reductions we have performed here in this example? Okay, screen is stuck. Okay, just give me a second. Okay, is this fine now? Is this fine? Okay, so here I was just saying, is this fine? Okay, I think now it is fine, right? Okay, great. So sorry about it. Now let's just start. I was just talking about this particular question, which is GATE 2020 question. Okay. So in this question, they are saying, what are the number of reduction steps taken by bottom-up parser while accepting this string triple A, D, and then triple B? Okay. So number of reduction steps they are asking. So just see here that that how many reductions we need to make, right? So before we solve this question, I just want you to know that what is this reduction, okay? And then you will be solving this question. So before that, before solving this question, let me tell you what is this reduction, okay? So now I hope everything is fine. If there is any issue, you can just let me know, okay? So let's just get started. So just tell me how many reductions are there. See, what is a reduction is that you are going from terminal to non-terminal, or basically reducing to the non-terminal. That is called reduction, okay? So this is one reduction, this is one reduction, this is another reduction, okay? Can you tell me how many total number of reductions that we have made in this particular example? How many total number of reductions here? Number of reductions. Let me write it. Number of reductions. See, this is 1, this is 2, then this is 3, right? Only 3. So here only 3. What about this? What about this? See, you need to make the make the bottom up parser tree or something like this, right? I mean, you need to ultimately make the tree. But since it is bottom up parser, we know it will be RMD in reverse. I mean, ultimately it is RMD in reverse, right? Ultimately it is RMD in reverse. Is this fine to everyone? So what we can do, we can basically find out RMD, right? And then we can find out the reduction, number of reductions, right? So RMD means we will be first reducing this B, capital A, capital S, small b. Then we will be reducing this capital S again. So we want to reduce it to small a. I mean, sorry, not reduce. Basically, we will be producing. Okay. I mean, this way is not called reduction. So basically, generally, this way is called reduction. I mean, going from bottom up is called reduction. Okay. So here you can say this capital S will be producing. Okay. So this is small a, small b, and then it will be small a, capital B, and then small s, right? Or capital S, right? So this is now next derivation. This is actually called derivation. Okay. This is called derivation. Right? And this way is called, this got reduced to capital S. This way is called reduction. I mean, this way is called reduction, and these are just terms. Okay, this way is called derivation. Understood? This way is called derivation. So now what I'm saying here is that that you just need to know that how many times you will be deriving, right? So from here, then here, then here, and then, so maybe I can just quickly tell you number of times that we will be deriving. Okay, so the string was triple A, D, and then triple B, right? Triple A, D, and then triple B. This is the string. Is this fine to everyone? Okay, okay. Now let's just do one thing. Let's just try to reduce, right? Or maybe we can derive from the rightmost derivation. Okay, then this is rightmost is capital B. So you will be reducing or you will be deriving using the capital B like this. And then there is only one, which is this. So this is the only rightmost. So A, B, and then this will be going to capital S, A, capital A, sorry, small a, capital S, and capital B, right? Okay. And then this will be going to A. Now here, this is the rightmost. Okay. A, S, and then B. And then since it is rightmost, you will be reducing it to B. Now again rightmost is capital S only. So you will be reducing, or you will be deriving to small a, capital B, and here it will be A, S, B. Is this fine to everyone? Let me know, right? And then what you will be doing next, you will be seeing here that, okay, rightmost is this. So again, you will be doing triple A, and then triple B, and then capital S, and then this will be D, right? Sorry, this will be B. These are the two B's, and then this will be B only. Okay, so this got reduced to, or this has derived this small b. Now this is again the rightmost. So here you will be you will be doing triple A, triple B, and then D, right? So how many reductions you made? So basically, if you check the reductions, you just need to check these, right? These arrows 1, 2, 3, 4, 5, 6, and 7. Is this fine to everyone? Okay, great. So I think you people have already studied this particular example. So I think this is fine, right? Now let's just move to the next things. Okay, let's just move to the next things. So as I told you that there are basically 4 types, right? 4 types of bottom-up parsers, and there has been many PYQs. I think we have just solved 2-3 PYQs, okay, which were easy one. This one was easy one, but honestly, this was not easy, okay. If you know that RMD in reverse and bottom-up parsers are same, then only you can solve these kind of questions. Otherwise, it is not easy to solve these kind of questions. By the way, coincidentally, I have also put this particular type of question in one of the test series, one of the test in compiler design. And later, to be honest, now you may not believe me, but yeah, later actually I got to know that this particular type of questions has already been asked in GATE. Actually, I did not know it. Okay, before putting this particular type of question, I did not know that GATE has already asked this question. But later I got to know that okay, GATE has already asked. I was thinking that maybe in future GATE may ask. When I was putting this question, this type of question that I was just asking for number of reduction steps, and I wanted aspirants to do this particular kind of derivations, this RMD, and I asked number of reduction steps. I thought that okay, GATE may ask in future, but later I got to know that GATE has already asked this kind of question. Okay. Now we will be, as I just told you, we will be studying these 4 types of bottom-up parsers. But before that, we have already seen what is RMD, right? We have seen what is RMD. Rightmost derivation, and we have seen that bottom-up parsers in general are same as reverse RMD, right? Are same as reverse RMD. Okay. Now we will be particularly moving to the types of parsers. Okay, that what are the types of parsers possible. But before that, you may ask one question to yourself. What is that question? That how to actually do it. See, in the sense that if we are deriving, for example, if we are deriving from let me just copy this particular slide. If we are deriving, let's suppose, from the string to the star symbol, then how to do it systematically. Okay, in the sense that let's suppose, let me remove this top down. Let's suppose this is the grammar that you have. Okay, and this is basically you will be doing bottom up way. Okay, for a given string. But how to do it systematically? When I'm saying systematically, I mean to say given this string ABA, right? Now you need to maintain some data structure, right? To basically do all of this parsing. Maybe you will be putting this A into stack. Okay, you will be putting this small a into the stack, and then you will saying that okay, now small b is left. Now should I be reducing this small a to capital A? So in the stack now it is capital A, something like that, right? So see, visually it looks good, right? Visually it looks good that okay, we will be going from left to right. So this is a visual representation. Okay, visually it looks good, but how to do it practically, or how to actually implement the parsers, right? Or how it is actually working. So basically, before we move to the types of parsers, okay, I want you to know the data structures used in the parser. Okay, so that once we cover the data structure that is being used in the parser, then you will be basically understanding all of these parsers in little more intuitive way. Okay, so let's just cover the data structure used in parser to implement those parsers. Okay, which is stack, actually stack. Once we know this, then most of the things will be very much clear about the bottom up parsing. Okay, then we will see specific types of bottom up parsing. Is this way okay to study this particular topic? Let me know. Okay, is this way okay to study this particular topic? Let me know. See, Generally, let me just tell you. Generally, in most of the coachings, at most of the place, you will directly get to know, okay, how to do LR0, how to do SLR1. You will not get the feeling. Okay, there is something called automata of these parsers, right? You will not get the feeling of these parsers automata. You will not get the feeling of the stack and all. You will just be mechanical about it. Okay, you given the grammar, you can just check whether it is LR0, SLR1, LLR1, LR1, like that only. But we should be having the feel of these parsers, and there are questions that has been asked, and that can be in the gate PYQs, right? And that can be solved only if you know the parsers in and out. So let's just try to understand these bottom up parsers in and out, right? Okay, great. Let's just start with the next topic, which is called stack of parser. Okay, stack of bottom up parsers. And then once we cover this stack, then we will be seeing all type of bottom up parsers. Okay, after this we will be seeing LR0, okay, SLR1. I mean, all of those four types. Okay, all of those four types we will be seeing. But before that, let's just see stack. So suppose this particular grammar is given to me, and I want to parse this, okay, in the bottom up way. Suppose I want to parse this in the bottom up way. Then how to parse this? You know this, right? I mean, maybe you can do RMD, or maybe you can just do this kind of tree. See, all of these are just visually, and how to implement what kind of parser we are using. Don't worry about it. Okay, we will be getting to know all of this. I mean, step by step. Okay, but currently I just want you to know that how to do it. As a human, as an algorithm, what algorithm and what kind of data structures we will be using, that we are not now going to see. But first, let's just see how to do it as a human. So basically, this ID will be reducing to capital E, and then this plus will be as it is. Then this ID will be reducing to capital E. Now, if you want, then you can reduce this to capital E, right? Then this multiplication is as it is. Then this is capital E, and then you can reduce these three to capital E. Okay, so this could be your tree. It is fine. This is the bottom up way. Okay, but this visual representation, these things are okay. But let's just do it, using data structure, which is stack. So what I will do, I will take this particular string in some array, I mean, or string. I mean, you can use string as a data structure for the input. For the input, actually, you can do any data structure. I mean, you can hold, or you can keep this input in the array or string or whatever. Okay, so maybe let's just keep this string in whatever data structure you want. Maybe I can keep this string in array, or maybe just directly string. Okay, I mean, this is, let's suppose, just one string. Actually, let me just end it with dollar, some special symbol, so that I get to know that there is an end of a string. Okay, I mean, algorithm get to know that end of a string has been arrived. Okay, so basically this is given input. This given input could be in any of the data structure of your choice. Okay, I mean, this is not part of algorithm, so let's not worry about it. Now let's just see how the algorithm might be working. Now what will algorithm do? Algorithm will see this ID. Okay, algorithm will see this ID and will put this into something called stack. So it will do something like this. Okay, it will put this ID into stack. There is some stack that it will maintain. Okay, so bottom up parsers maintain stack. Understood? Now once you put this, there is always one question: should I reduce it or not? Tell me, is the first ID reduced or not? So we can reduce it, right? So we can definitely reduce it to capital E. I mean, once you put in the stack, then only you will be calling, or you will be making this decision. Now the stack contains, stack contains capital E only. Is this fine to everyone? Let me know. This is fine, right? Okay. Okay. Now, now basically you will be pushing this plus now in the stack. Okay, so plus in the stack. Now you will be pushing the ID again in the stack, and then you will be reducing it to capital E. So basically plus is pushed, ID is pushed. So basically in the stack, it is contained something like this. Okay, in the stack it is contained something like this. Is this fine? Now this, as you know, that this E plus E is getting reduced to capital E. So basically this whole thing in the stack, okay, whole thing in the stack is getting reduced to capital E. So this whole thing you will reduce it to capital E. Understood? I mean, this is, you can say this is basically reduced, right? Now you will be pushing the next symbol, which is star, and then you will be pushing the next symbol, which is ID. Okay, which is ID. You will be pushing the next symbol, which is ID. Now this ID will be reduced to capital E. So your stack will look something like this. Maybe I can just adjust the space here only. So your stack will look something like this. See, just see here, it is actually easy. If you do it, then also you will realize it is easy. Okay, I mean, this ID will get reduced to capital E. Now you notice that this whole thing will get reduced to capital E, right, directly. Now once you have capital E, and then only dollar is left because ID has been pushed, only dollar is left, then it is called acceptance state. Okay, so basically in the input only dollar is left. Okay, all of the input is consumed, and in the stack capital is there or start symbol is there. Okay, then it is called, this is basically given input, and then you have consumed all of the input, and the only dollar is left, and on the stack capital is there, only capital is there, then it is called accept state. I mean, this string has been accepted. Okay, I mean, this is just first example, we will just understand it more. But is this clear? Is this little bit clear now that what we are doing? Is this a little bit clear? I hope that is clear, right? That what we are trying to do. Okay. Now maybe we can do another example, but before that, don't you think this stack, making the stack and all, looks like clumsy? Looks like little bit, clumsy. I mean, it is taking too much of a space. I mean, it is your opinion. You may say that okay, it is not clumsy, it is neat and clean, which I will definitely appreciate because it is ultimately my handwriting. Okay, so if you are saying that this is neat and clean, so I will appreciate it. But still, don't you think it is clumsy? Let me know. So basically, since it is not looking so good, let's just do one thing. Let's just have some different notation, just for the notation purpose I'm saying. Okay, so basically what I'm trying to say here is that instead of making the stack again and again, so much of space and all, it is so much headache. Instead of making the stack, let me do one thing. Let me make bar. Okay, bar in the sense just a vertical bar. Okay, which means which means if this string is given to me, id plus id cross id, okay, or multiplication id, then what will I do? I will, instead of maintaining the stack, okay, I will maintain the bar, which is very easy to maintain. Okay, I will just say that okay, this, which means left of this is on the stack. Okay, this is on the stack, and this is the input that yet to be read. Okay, that this is the input that I have not read yet. Is this fine to everyone? That what I'm trying to say, right? So basically the point here is that I will say that I will maintain this kind of structure where this is the string, right? So I'm removing this tree. It is not of much use. Okay, so I'm just telling you some some working of the LR parsers. I mean, all of the LR parsers work in the same way. So how does they work? They will be keep on putting in the stack. So instead of making the stack, I will be just saying okay, initially this is the state, right? And then what is the state? The next state is basically this bar will be getting shift. This bar, or you can make a dot or anything, but I'm just making a bar. Okay, so this bar will be getting shift. Okay, which means now if I'm writing like this, okay, if I'm writing like this, can you tell me what is on the stack currently? Just let me know in the comment section what is on the stack on currently. Currently, what is on the stack? See, this notation I'm just asking you, id is on the stack, right? I mean, id is on the stack, right? So I think most of the people have given correct answer. Okay, that id is on the stack. Now since it is on the stack and you will reduce it to capital E, so basically the next state is capital E plus id cross id dollar, right? So now what is on the stack? What is on the stack? This capital E is on the stack. So see, this is just a notational thing. Okay, I'm not changing the algorithm, I'm just changing my way of writing. This is actually not exactly my way. I have seen this in one of the top university. Okay, and and I will not I will not give the name, because I have observed that people started copying Go classes lectures. So there are few things that I have noticed, that people started copying Go classes lectures. So if I can say this is one of the unique way that I have found out, and that is very at very first place only. Okay, I mean that is only at very unique places. So this is not easy to find out this kind of notation at everywhere. So if someone is copying, okay, this kind of notation, then I will in future I will get to know that they have copied from Go classes lectures only. Okay, because I started noticing that people started copying our lectures. Okay, either it is gate CSE or gate DA. Anyway, so is this fine to everyone? Okay, now you will be basically pushing this plus to the stack. So basically the next state will be something like this. Okay, maybe I can move to the next slide to explain this more clearly. So the next state is, right, and now again and again you can keep on doing it. Basically the next state will be capital E plus ID, and then into ID dollar, and then this ID will be getting reduced, right, to capital E, and then this cross will get shifted, and then ID will get shifted. Actually I'm doing it very step by step, that is why you might see that okay, there are too many steps, otherwise it's very easy to do it. Okay, so basically I mean that is your choice, but I'm not going into much detail. I mean you can push this or you can shift this cross, or maybe you can reduce here itself. Okay, you can reduce here itself. So basically this whole thing you can reduce to capital E. So I'm just reducing it to capital E, and then this will be like this, and then you will be pushing both. I mean it will be the two steps, but I'm doing it just one step. Okay, and then E dollar, right? And again this is called accept state, where in the stack you have start symbol, and in the input you have dollar. I mean there is end of the input. Okay, cool. So basically you will be starting from ID, and then you will be doing this like this, and that is systematically been done using stack. Okay, using stack you can systematically do it. So by the way, I've taken this from our lecture slide. Okay, I mean I have already taken lecture on this in Go classes lecture. So if I'm writing lecture slide, it means it is from the paid lectures that I've already taken. Okay, so using stack you can systematically do it. So how? You will say that okay, this is read and that is in the stack, and that this is yet to read. Okay, so using stack you can step by step, just like this. Okay, just like this you can do it. See, okay, these are the steps. Using these you can basically call, this is called parsing. You can parse this. Okay, these are the lecture slides, you can parse it. Is this fine? Little bit, is this okay that what we are doing? So I am just introducing that how this algorithm is working. Okay, as per the implementation perspective, I mean using which data structure it is working. Okay, that what is the data structure using which it is working. Okay, I'm just telling you this thing. Is this fine to everyone? Great. So basically our general notation will be, this is in the stack and that is already read, and this is yet to read. Okay, this will be our general notation now on. I mean you can make a stack, but I think vertical bar is more suitable. Okay, now let's just parse this also, so that you are just used to of the stack, that how this stack is working. So this is AAB. Now you know that okay, this is AAB. I think these are the A only. So maybe this A will be going to capital B, and then this whole thing will be going to capital A, right? So these are the only two reductions. How to do it using stack? Very easy. This is A, B, okay. Then you will be pushing this A, okay. You will be pushing this A, and then this small a will be reducing to capital B, AB. Then you will be pushing both of this. I mean, one by one, obviously one by one, right? You will be pushing one by one both of this, and then you will say that okay, this whole thing. So if you want, you can keep the dollar at the last. You can say this whole thing is basically capital A only. So finally you got capital A, which is start symbol, and dollar. This is called accept state. Right? Very easily you can do it. Where screen? Why this is getting stuck? I don't know. Okay, just a second. Hello. Okay, so I think now it will be clear. Okay, so basically, I was just talking about this example. Okay, so let me do one thing. Maybe it might get stuck later on also. So let me just keep eye on this, that it should not get stuck. Okay, just a second. Give me a second so that I can just adjust it. For the entire lecture. Okay. So I will be keeping eye on this. Okay. No, I'm seeing chat only, but then only I get to know. Okay, I'm seeing chat again and again, but actually there is always a delay between the chat and what I speak, because that is because of YouTube. Okay, in the YouTube there is always a delay of 5 to 10 seconds, or maybe 5 to 7, 8 seconds. Okay, but I hope now it is fine, and then I will be keeping eye on this. If there is any problem, I will be immediately checking it. Okay, so. Let's just see what they are saying. So they are saying that parse this string using the bottom of parser, right? So what you need to do, you need to do it step by step. Okay, how to do it? Basically you will be just having this small a and small b, and then you will be basically saying that okay, we need to use what, we need to use stack here, right? So you will be first, or maybe I can just tell you, basically you will be first making the tree. So small b, then first to make the tree, so it is capital B, and then you will say that okay, this is capital A, right? Ultimately this is capital A. Is this fine to everyone? Right? Okay, great. Now what you need to do, you basically need to do the whole thing using stack only, right? How to do it using stack? You will say that okay, let's just first push this small a. Okay, so basically if you push this small a, then let me put dollar at the last. Okay, and then you will say that okay, if you are pushing this small a, then this small a will get reduced to capital B, right? And then you will be pushing small b, I mean step by step, and then you will say this whole thing in the stack, this whole thing is basically capital A, right? And then dollar. Is this fine to everyone? Okay, this whole thing is capital A and then dollar, and this is basically called accept state. Okay, this is basically called accept state. Okay, so Muskan Mora is asking, shouldn't bar be in second step in after 8? After A, see, I have just pushed it, A, B. I mean, you can do it step by step, but I have just, shown two steps at the same time. Or you can just do it step by step. Both the things are fine. Okay, both the things are fine. Okay, great. So, so basically, I just told you that how this stack is working, right? How this stack is working. Now you got to know that how this stack is working. Okay, that is the only purpose of this particular topic. Now you might notice, or you might say that why we are even studying this. Are there any gate PYQs? Yes. So basically, I mean, not directly. There might not have been directly asked, but I will just tell you that in what way gate PYQs are asked using this particular concept. Okay. Okay. Now let's just parse this string. Okay, using the stack. This is interesting. Which is C A B A power A B whole power n, right? Let's just parse this string using the stack. This is going to be actually interesting. So what you need to do, you just need to tell me that, let's suppose this is A B many times. Okay, A B. Okay, 3 to 4 times. Okay, you just need to tell me how this stack will be working. So basically, you will say that, okay, this bar will be shifted, right? And then this will be capital S, isn't it? This will be capital S. Is this fine to everyone? Now, basically, you will say that this capital S is already there, and now you ultimately want capital S AB so that you can go to capital S again. So you will be pushing this AB. I mean, I'm not doing it step by step, but you got to know, right, that you will be pushing this AB now. So now this is capital S AB. Okay, this will be capital S AB, and then this is AB. Okay, and then ultimately, let's suppose this AB is many times. Okay, or maybe I can just take it 3-4 times for the sake of explanation, and later on I will be just saying it could be even many times, doesn't matter. Okay. Okay, now what will happen? Now you will say this capital S AB will be going to capital S, and then AB 3 times will remain. Okay, and then you will be pushing this AB, and then 2 times will remain, and this will be capital S, then AB, right, like this. Then then again, this capital S AB, this is AB, this is capital S, only one time will remain, then capital S AB, and nothing will remain. This is capital S. I mean, nothing in the sense, at the end, if you want, I can just put dollar. Okay, so dollar will remain, capital S, and then dollar will remain. Is this fine to everyone? Let me know. Okay, great. Now let's just do the similar kind of example. So I will just tell you that why we are doing all of this. Okay, let's just do the similar kind of example, but instead of capital S small ab. Okay, capital S small ab, basically here what we have done, we have basically reduced this to capital S, then this whole thing to capital S, then this whole thing to, I mean, I'm reducing again and again, right? But the similar kind of example, but instead of capital S ab, I have here capital AB and then sorry, small AB and then capital S. Okay, AB and S. I have AB and S. Okay, this is the only difference, in the sense that we have the same thing, but here I just have AB and S. Okay, so what you need to do, you will be having AB, let's suppose 3 times, and then C. Okay, then this is dollar. Okay, so basically you will be pushing this AB, right? You will be pushing this AB. After pushing this AB, you will be noticing that you have something like this. Okay, after pushing this AB, you have something like this. Now you will see that, okay, since I have something like this, then can I reduce, I mean, you will be basically pushing one by one, by the way, but I have pushed it directly. But you will say that, can I reduce this AB to something? Tell me, can I reduce this AB to something? Is this possible that we can reduce this AB to something? Let me know. Just a second. Is this possible? No, right? So basically you can't reduce this AB to something. You have to basically say that, okay, I will be again pushing the next AB, and then this will be ABC. Okay, then I will be pushing the next AB. Okay, then I will pushing the next AB. Then I will pushing the next. Okay, again I cannot reduce anything, right? Then I will pushing the C. Then I got to know, okay, actually I will just tell you later on also that we will always reduce on the top of the stack. Okay, in the sense that we will if there is a reduction possible, we will do it on the top of the stack. Okay, so this ABC now can get reduced, or maybe sorry, the C can get reduced first to capital S, right? The C can get reduced to capital S, right? So I will be reducing the C to capital S. So tell me, isn't it the very first time we are doing the reduction? Okay, so these are the AB, these are the 3 AB, and then small c has been pushed, right? Small c has been pushed. Now you will be doing the very first time reduction. Okay, this is the reduction that you have done very first time, isn't it? I mean, you keep on pushing, and this is the very first time you are doing the reduction here. Okay, I mean, this is small c to capital S. This is the reduction that we are doing, but this is the first reduction that we have made, right? Okay, now we will be reducing this ABS to capital S. So now it will be something like this: AB. Now ABS to capital S, right? So capital S and then dollar. Is this fine to everyone? Now you will be reducing this ABS to capital S. So again there will be AB and then capital S and then dollar. And then this ABS to capital S. So yes. So actually after it has got reduced. But before that it was shift only, right? I mean, before this it was shift only. You were shifting only. You started the reduction here. After certain point, once you have seen the C, because the first reduction has to be made on C, right? The first reduction has to be made on C. Until and unless you see this C, you cannot reduce. Is this fine to everyone? Until and unless you see this C, right? You cannot reduce. So that is one very important point. And that led to one of the aimt question that we have put last year. Okay. So basically you notice here is that you keep on pushing, but ultimate until unless you see, because this has to be the first reduction, right? You see this C, you will be keep on pushing. Okay. You will be keep on pushing until unless you see this C. Let me know if that is fine. Is this fine? Okay. So basically, you can see the stack is taking too much space. In the sense, if these are the n ABs, can you tell me how many space the stack will be taking? I mean, how could be the stack size? Stack size could be very big here, right? Depending on the n, isn't it? Stack size could be very big. So the stack size here could be n only. I mean, order of n, right? In the theta of n. Is this fine to everyone? But if you notice the last example, the previous example here, okay, here the first reduction has to be again made on C only, but C we have seen very first. Then the stack is just containing 2-3 symbols always. Okay, just see after this AB, you will be again reducing, isn't it? So stack is only containing 2-3 symbols always. If you notice the stack, okay. So in the sense that stack space here is just constant. Stack space is here just constant. But how much stack you have taken there? You have taken too much, right? Stack space there is much, but here is just constant. So basically, don't worry. I will just summarize everything step by step. What I mean to say, suppose you have this question, okay, or maybe let me give you easier question. Let's suppose you have this question. This is first grammar, and let's suppose instead of AS you have SA. This is left recursive grammar, okay. This is the second grammar, or maybe if you are much comfortable, I can use capital A as a symbol. I think S is fine, right? Okay, whatever. So S is fine. So let's suppose this is a grammar 1. This is grammar 2, right? This grammar is producing a star or a plus, something like this. I mean, this kind of language, right? This grammar will be producing ba plus. I mean, the languages are different. I'm not saying languages are same, but they're almost same. The grammar looks almost same, right? Now, if you observe here that if you use the bottom up parsing, then what you need to do, let's suppose you want to parse a power n here, a power n b you want to parse here, you want to parse b a power n. Okay, you want to parse this string here, you want to parse this string here, right? Now suppose this is also a, then actually both could be a power n. Okay, if you want I can take both to be a power n, but let's just understand with this first. Okay, so you want to parse this. Now what you will do, your first reduction will be on b actually, right? So you will say that okay, a n times, and then b, you want to parse this. So stack will be containing this, and then 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 stack will be containing this, then stack will be containing till this point, and then stack will be containing this. Then you will say, oh, the first reduction has to be on b. So that is why this is the first reduction, which is capital S. Now this is the second reduction, which is capitalized. Now there will be a here, alright. This is the third reduction, which is capitalized. So basically stack ultimately has to have all of these symbols, right? There will be this kind of state that will be there in the stack. Is this understood to everyone or not? Let me know. Right? So basically what I'm trying to say here is that in this particular case, the first case, the stack size is basically order of or theta of n. See, time complexity will be same only. I mean, with respect to time, it will be just theta of n. I mean, it is linear. Okay. So space complexity here space complexity will be theta of n, but here space complexity will be just or theta of 1. I mean, if you just only ask me the stack, okay, in the sense that for the input definitely there will be some space, but if you only ask me with respect to the stack, it will be just theta of 1. Okay. So basically here the input is b a, right, and then dollar. So here you will say okay, you will see this b, you will be reducing it immediately to capital S, and then capital S, capital A, you will, once you push it, you will reducing it to capital S. So in the stack there will be 2-3 symbols at most at a time. Okay, in the stack there will be at most 2-3 symbols at a time. Is this okay to everyone or not? Is this fine? Let me know. Right? So now can you solve this question which we have put in aimt? This is one of the aimt question last year. Okay, I mean not exactly this. I think we have put the questions like grammar 1 will take theta of 1 and g2 will take theta of n. This was one of the option. I mean there are 4 combinations, right? G1 will take theta of n, g2 will take theta of 1, both will take theta of n space and stack space. Okay, both will take theta of 1 space. Okay, so this is regarding the stack space. So which is correct option? See here the first reduction will be okay, you actually need to do it. So see here, you will be doing AB, right? I mean this is like AB. Ultimately it is both are having AB power n, right? So here you will be pushing it AB, and then by seeing this AB, can you do it capital S? See, if you do it capital S, then capital S AB is nothing here, right? Capital S AB is nothing here. It has to be basically AB all the pushed, and then last AB you have to say this is capital S, because ABS is making sense here. ABS is making sense here. If by saying the first AB you reduce it to capital S, then capital S AB will not make any sense further. Okay, so you have to keep on pushing, and last AB you will say this is capital S and this is AB capital S, right? Like this. Are you getting my point? So let me do it basically on the next page. What I'm trying to say is like this. See, both the grammars are producing the same language here. Okay, now let's just see the first one. Let's suppose this is the string a b a b a b a b a b a b dollar, something like this, right? So here, if you, in the first example, if you notice, if you do this, I mean, you will be pushing a and b. If you just reduce it to capital S, then it will be a problem for the further, because capital S a b is not making any sense in the future. Okay, so that is why you will not be doing for the first ab. You have to keep on pushing, and you will be doing for the last ab. Once you push the last ab, then this is capital S, then you will say this is again capital S, now this is capital S, then this is capital S, and ultimately all of this will be capital S only. Okay, so first will take how much stack space? This will take stack space of theta of n. This will take stack space of theta of 1. Why? Because for string is same, but for first AB you will be reducing it to capital S, and then capital S AB will make sense in future. So capital S AB will make sense in future. I mean, this is again a capital S. Okay, so in a stack, just 1-2 elements are always there, right? I mean, the constant number of elements. Is this fine to everyone? Let me know. Okay. This is fine, right? Great. Now, now basically the conclusion here is that if you notice here, right, if it is left recursion, actually left recursion is good. Okay, I mean, with respect to at least space complexity, left recursion is good. For bottom up parser. Okay, with respect to at least space complexity, you can say. So you can say, I have taken this from IIT Madras. Left recursion limits the stack space. It is good. Left recursion is good for bottom up parsers, but it is bad for top down parsers. Okay, but bad for top down parsers. Why that is the case? Because LL1, if it is left recursive, then LL1 cannot parse it. Okay, for the left recursive grammar, LL1 cannot parse it. Okay. Okay, now you know what is the stack, right? See, we have just covered the stack. That what is the stack? Okay, so we have covered what is the stack, right? You little bit now you know, right? What is the stack? Now you know what is the why we called bottom up as reverse in RMD. Okay, so basically these are the two things which are clear to you guys, right? Let me know if there is any confusion here. How bottom up work, and I mean overall understanding may be little bit clear. Now let's just see the type of specific parsers which are called LR0, SLR1, LALR1, and LR1. Okay, these are the four specific type of parsers. Let's just see these parsers. Let me know before if there is any doubt. Okay, so someone is asking if there is more than one RMD, then no bottom up parser can parse it. Okay, so you will get to understand these things basically. So no bottom up parser can parse it. It is ambiguous grammar. It is called ambiguous grammar. And no bottom up parser, or no parser actually. Most probably no parser, but let me write it. No LR parser. Okay, no LR parser can parse it. Okay, great. Can you answer this question? Which of the following? This has been asking GATE 2024. Very recent, right? Very recently they have asked this question. Which of the following is or are? This is MSQ. Bottom up parsers. Shift reduced parsers are called actually bottom up parsers, and these are LR parsers. Okay. Predictive parser LR1. These are the top down. top down parsers. Okay. Sometimes get asked these kind of questions also. Great. Now let's just start with LR0 and SLR1. Okay. So I want to give you 5-minute break. Should we give it now or after 1 hour? Let me know. The 5-minute break, should we do it now or after 1 hour? So LR0 and SLR1 parsers, these are the two parsers we will study first, and then we will study. So we will study these as one. We will study these as together basically. Okay, and then we will study these two together. Okay, so in a couple or in a pair we will study. Understood? So let's just see LR0 and SLR1 parsers. Now there is something called as LR0 item. Okay, because LR0 item is something which these parsers are using, okay, to draw their automaton. So basically what is this? Suppose there is some production, so I will be using a dot. Okay, dot means that I have seen, let's suppose alpha dot beta. That what does this mean? That I have seen alpha and I am expecting to see beta. And once I see alpha and beta both, then I will be reducing it to capital X. Okay, so this means I have seen alpha, I'm expecting to see beta. Okay, great. Now this X means that once I see alpha and beta both, then I will be reducing to X. Okay, you will understand this. This is called, by the way, LR0 item. So you will understand this. Closure means that add LR0 items to I, okay, until there are no more to add. For example, let's suppose this is some grammar. Okay, this is some grammar, and I want to find out closure of some item. Uh, let's suppose I'm just saying this is some LR0 item. Okay, this is called item, LR0 item. Okay, this is basically called LR0 item. Now now this dot means that I'm expecting to, I have already seen, basically it is just a starting item, I have not seen anything, but I'm expecting to see this BCD. Now you will get to understand that what do I mean by that. Okay, see, can you see in the input, can you see, let's suppose this is the input, can you see the capital symbol in the input ever? Can you see capital symbol? Can you see capital B, capital C, capital D in the input ever? Can you ever see capital B, capital C? No, right? So what does this mean? What does this mean? That I'm expecting to see BCD. Can anyone tell me in the chat that what does this mean? It actually means that I will be seeing something which will be reduced to capital B. I will be seeing something which will be reduced to capital C and which will be reduced to capital D. Okay. So basically I will be seeing something which will reduce to capital B because I cannot see capital B directly. Okay. Anyway, so let me first tell you what is the closure meaning. So we will start with any of the item. Let's suppose they are asking you to find out the closure of this item. Okay, this is the starting item, by the way. Okay, so this is LR0 item. So to find the closure, what you need to do? You need to take. Okay, you need to basically take all the productions of this capital B. Okay, all the productions of this capital B, because the dot is in front of capital B. See, if the dot is in front of capital B, you will be writing all the productions of capital B. Okay, which means now this dot is in front of whom? Now this dot is in front of whom? Now dot is in front of capital A, right? Now since dot is in front of capital A, now what will we be doing? We will be writing all the productions of capital A now. Okay, so we will be writing all the productions of capital A. So which means, and that is all. Okay, that is all. That is the closure. Okay, that is the closure of this item. Okay, so how to find out the closure of the item? you basically have to find out all the productions of, you have to list out all the productions of B, and now the dot will be here. Now since because there's a dot in front of capital A, so find out all the productions of capital A. Okay, I mean list out all the productions of capital A. This is called closure of any item. Or let's suppose this item. Okay. Is this fine? Let me know if there is any doubt. If there is any doubt, then I will just clarify this. Otherwise, it should be mostly fine. Okay. So what is a closure? You will be basically just taking some item, okay, and then you will be listing out all the items for which you have the dot. For example, this dot is in front of capital B. You will be writing all the productions of capital B. Okay, that's very simple. Let me know that is okay or not. Okay, great, right? It is fine. Now let's take another another example. For example, we need to find out the closure. So it is very easy here. Let's suppose there is one, actually we add one augment, this is called augmented production. Okay, so we add one production, and then we say that, okay, let's suppose we find out the closure, right, of this particular augmented production. So what will the closure of this? You need to list out all the productions of S. Now there is no dot in front of any capital symbol, right? I mean, if you list down, then you will just stop here. So this is, one item set. Okay, this is called item set. Is this fine? Now from this item or item set, I mean, you can say item or item set, doesn't matter much. Okay, from this item, what you need to do, you need to basically go to some other item. Okay, so if small a comes, then you will be shifting the dot to further. So you will say that, okay, then capital S will be small a dot a and small a, and here there is no small a, so that is fine. And if capital S comes, then you will be moving the dot further to capital S, right, like this. Okay, is this fine to everyone? Now here if dollar comes, then you will be saying that, okay, if dollar comes, if here, from here, if small a comes, if small a comes, if small b comes, is this fine to everyone? Okay, I think got stuck, right? Okay, I don't know why that is happening. Just a second. I'm sorry about it. So now it is fine, right? I don't know why this is happening today, but I'm closely checking it again and again. I cannot even stop the recording or something, because it will eventually stop this, the streaming. Let me just check that why this is happening. Just give me a second. Yes. So I will be repeating. I will be just repeating. So what I'm saying here is that, so I think it got stuck at this moment, right? Okay. So let me just repeat it again. So basically what I'm saying, that if you have, let's suppose this particular grammar, right, then there is something called augmented production. So first we will be basically having the augmented production. Okay, so this is the augmented production. Is this fine to everyone? First there will be the augmented production. Okay, now what we will be doing, we will be basically finding out the closure of this augmented production. So which means if dot is in front of capital S, now we will be writing out all the productions of capital S. Is this fine? Okay, then we will say that okay, this is first item. Then we will be moving, or we will be shifting on A, on the capital or small, right? I mean, here the dot is in front of A, so you will be shifting on A. So if A comes, then you will be shifting like this. I mean, you will be shifting this dot here also, if A comes, right? If capital S comes here, you will be shifting this dot further. Okay, you will be shifting this dot further. So which means, right, if capital S comes, you will be shifting this dot further. If here, if small a comes, then you will be shifting this dot further. Okay, so like this. If small b comes, you will be shifting this dot further on the next production. Is this fine to everyone? Basically we will be having some grammar, and then we will be adding, this is the very first step, augmented production, right? And then if the dot is in front of capital S, we will be writing all the productions of capital S, and then we will be just seeing that okay, if small comes, then what will happen, if capital comes, then what will happen. We will be just keep on shifting these dots, okay, depending on what input symbol is there. Okay, what symbol is there. Okay, so yes, I was talking about this closure slide only. So we will be basically writing all the productions. I mean, this actually got completed. Okay, this actually got completed. I mean, there was nothing more I wanted to say in this closure. Okay, so maybe I think a little bit I need to add here. Let me just tell you again that what is the closure. So how to find out the closure? Let's suppose I want to find out the closure of this. Okay, let's suppose I want to find out the closure of this. Then what will I do? I will be basically saying, since dot is okay, since dot is in front of capital B, I will be writing all the productions of capital B. Is this fine? If dot is in front of capital B, let me know. So by the way, just give me a second, maybe I can just fix it permanently. Okay, so most probably it will be permanently fixed. Great. So now you might not see my cursor, but that is fine. Actually, I wanted to just have the cursor in the in the presentation. So that is why I just made some changes, but I think those changes are making some trouble. Okay. So it will not stuck. Most probably now it will not stuck. Okay. Now it will be fine only. Right. Now let's just continue. Great. So basically what I'm saying, if dot is in front of capital B, I will be writing all the productions of capital B. And then if dot is in front of capital A, I will be writing all the productions of capital A. Okay. So this is the closure of some item. Let's suppose this. Okay. So this is called closure of an item. Okay. This is the closure of S gives dot BCD. Okay. This is the closure of S gives dot BCD. Is this fine to everyone? Is this fine to everyone? Let me know. Okay. Okay. Now I was talking about this particular grammar, right? For this particular grammar, if you write down the augmented production, this is called augmented production, and then since this dot is in front of s, you will be writing all the productions of s, right? And then on a small a it will be shifting, on capital S it will be shifting, on a small a it will be shifting like this, right? Maybe with the more examples it will be more clear. So let's just directly do this. Okay, let's just directly do this. Suppose you write the augmented production first. Okay, now what to do? You will be basically writing, because of this capital A, you will be writing all the productions of capital A. Okay, so this is your one item. On capital A, it will be shifted on capital A like this. Okay, is this fine? Is this fine to you? Now on small a, it will be shifted like this. On small c, it will be shifted like this. Okay, now on capital A, it will be shifted like this. So basically here we have just missed one thing. What is that? We need to write all the productions of capital A again. So basically we need to always find the closure. So what I'm trying to say here is that on small a, it will be shifted, right? The small a, you just notice one thing, the dot will be shifted like this. So which means capital A, this, right? But because this dot is in front of some capital symbol, that is why write all the productions of capital A. Write all the productions of capital A. Okay, is this fine to everyone? Now uh, now on capital A you will be shifting it, and on small a, see, on small a you will be shifting this, right? This dot further. Now you notice interestingly, on small a, to whatever you will be shifting, it will be the same state. I mean, it is a self loop. See here, on a small a you will be shifting, right? So to whatever you will be shifting, it will be the self loop only, in the sense that it will be the similar state, or the same state. On a small a, it will be capital A. See, this will be shifted, right? And then because of this dot, you need to write all the productions of A. Okay, you need to write all the productions of A. So basically these two states are actually same. So that is why you can say it is a self loop. Okay, that is why you can say it is a self loop, because these two states you can just match, these are same. So you can just say it is a self loop. Instead of making a next state, you can say on a small a it will be a self loop. Understood? Now on capital A, it will be like this. Okay, on a small a, I think we are done. On capital A also we are done. On a small c we are left, right? On a small c, it will be the state which is the same as this. Okay, on capital B, sorry, on small b, it will be something like this. Okay, on a small b, it will be something like this. Is this fine to you? Now now I think on capital A, see, dot is in front of capital A, we are done. On dot is in front of small a, we are done for the small a. Dot is in front of small c, we are done for the small c also. Okay, we are done for the small c also. Okay, for this state everything is done. I think we have made the automata, right? Now you can also say on the dollar it will be something like this. Okay, you can also say something like this. So we are done with this, with the automata, in the sense that we have started with this. Okay, we have started with this, and then we are saying if capital A comes, then I will be going like this, and then so on, right? On if small a comes, then I will be going like this. And since the dot is in front of this capital A, so I will be basically writing all the productions of capital A again. So this is called LR0 automaton. Okay, is this fine to everyone, that how we are making this automata? Now we can do more examples, and then you can probably understand that how we are making this automata. Okay, so for example, maybe I can just take another example. Okay, now what is the first step? You actually have to have augmented production. Okay, what is the augmented production? You will be just saying that s dash gives dot s dollar. This is the augmented production, and because of this you will be writing all the productions of capital S. These are all the productions of capital S, right? Now you will be writing all the productions of capital S you have written. Now okay, now tell me, will you be writing all the productions of capital A also in the same item? Tell me, in the same state. In the same state, will you be writing all the productions of capital A also? No, right? In the same state, you will not be writing. Why? Because there is no dot in front of capital A. You will be writing only if the dot is in front of capital A. Okay. So you will say that, okay, this is one state. These are called also state. Okay. State. These are called items. This is one item. This is another item. This whole thing you can say item set or state. Okay. You can call it state. Now, if small a comes, then you will be going to capital S, small a dot B, capital A. Now, if small b comes, then it is interesting, because now you need to write all the productions of capital A also. So these are all the productions of capital A. Now here, if small a comes, it is separate. If capital A comes, it is like this, right? Now here, if small b comes, now it is again interesting. Why? Okay, sorry, small b is done. I think this is done. Okay, everything is done, right? Okay, from here you can say if capital S comes, it is actually straightforward. If capital S comes, and then if dollar comes, then you can shift it if you want it. Is this fine to everyone, that how we are making the automaton? Right? Okay, great. So basically I just told you the how to make the automaton, right? Now we will also see that how to use it. See, how to make it, actually most of the students know. Okay, I can guarantee it, like if you have already studied compiler design, then I can say 100% students who have studied compiler design know how to make it. But how to use it, or how to understand that what these are doing, that rarely everyone know. Okay, I mean rarely anyone know. So how to use it is actually not known to people. Okay, it is not known to people, but we will see that how to use it, or how to understand this automaton, which means that what do I mean to say that capital A comes. See, can this capital A can come? Can this capital A can come in the input? Can input have the capital symbols? No, right? Input cannot have the capital symbols. This input cannot have the capital symbols. So what do I mean to say that if capital A comes? These things we will understand. Okay, so see, currently I have just told you that how to make the automaton. How to make it is very easy, right? Again, we will see with the many other examples, but before that, let's just see, or let's just practice using gate PYQs. So this question has been asked in gate 2019. Okay, so let's just practice using this PYQ. So what they are saying, there is some production or some grammar that is given to you. They're asking you for the closure. See, generally we write dollar at the end, but that is fine if they are not writing. Okay, they're asking you to for the closure of this, the number of items in this closure. Okay, number of items in the set go to of this. Okay, so basically this move is called go to. Okay, these are called go to or shift moves. So they are asking that what is the number of items in the if we shift on small a, or maybe let's suppose if we shift on this bracket, then what are the number of items. So basically, let me just go to the next page. Let me tell you that how to solve this question. Okay, so can you make the automaton? Basically, can you make the automaton? See what they are saying, given this. Okay, you can put the dollar if you are habitual with the dollar. Actually, it will not harm you. If you are habitual, you can put the dollar. So there will be a dot here, and there will be a dot here. There will be a dot here. Will you be writing all the productions of L also? No, because L is there is no dot in front of L. So the closure closure of this particular thing that they are saying is I0 actually, which is this. See, see, they are saying given this, okay, given this, we need to find out the closure of this first thing, right? So basically, let me write the grammar separately, okay, and then let me tell you how to find out the closure. So what is the closure? You will be writing dot, okay, because that is given here already, right? Dot is in front of s, dot s, right? And then all the productions of s, dot id, okay, all the productions of s. Is this fine to you? And then once that is done, okay, once that is done, you will say, that okay, since it is done, okay, you will say it is basically one item set, or you can call it state, okay, this is one state. Now tell me, will you be writing all the productions of L also? Should you be writing all the productions of L? No. Why? Because there is no dot in front of L. Dot is in front of a small symbol, dot is in front of a small symbol, or the terminals, right? Dot is not in front of L. So this is the I0, because I0 is what they have defined, the closure of this, right? So closure of this we have found out, and this is what they are calling I0. Now they are saying go to. Go to means you are shifting on this small symbol, open parenthesis. Sorry, this angular open parenthesis, right? If you are having go to on this, then what you will do? S gives dot, because it will get shifted here, right? L, like this, right? I mean, it will be like this, and all the productions of L also, comma S dot S. Now because of this dot, all the production of L also will come, but since you have written all the productions of L, so it is not contributing anything. I mean, this dot is not contributing anything, because you have already written all the productions of S, of L, right? So that is why this dot will contribute, and you will be writing all the productions of S now. So if you write all the productions of S, okay, from starting, it is, these are the productions of S, right? So can you tell me how many, what they have asked, how many items here in this go to? This is called this move is called go to move. Can you tell me how many items are here? Just let me know. You can just count it, right? Very easily. This is 1, 2, 3, 4, 5. Okay, so 5 items are here. I mean, basically these are the 2 items, in the sense that it is basically L gives dot L S, and it is L gives dot S. I mean, these are the 2 items, not 1 item. Okay, so that is why total is 5. So what is the answer of this GATE 2020 GATE 2019 question? 5, right? 5 is the answer. Is this understood to you guys? Let me know. Okay, great. Now let's just move to the next question. Okay, let's just move to the next question that has been asked again very recently. They're saying that consider the following grammar. These are the terminals and all. Okay, this is the grammar. Okay, now they have again asked you for the start symbol only. They are saying let I0 be the closure of this. The number of items in the set, go to. Okay, so they are saying you are doing 2 times go to. Okay, so let's just do it. Do you want to do it, or should I do it now? So maybe we can do it quickly, right? It will not take much time. So basically here they are asking you to go to do 2 times you to go to. Let me do one thing. Let me basically write the closure of just a second. Okay, just give me a second. Okay, so what I'm saying, sorry, actually there was some courier. Okay, so basically if you find out the closure, I've just taken the solution, because I mean, instead of writing it all, basically you can just put the dot everywhere, right? I mean dot s, so dot dot dot, and all the productions of s. So actually s is only there, so I've just put the dot everywhere, right? So you will be having this as the closure, but you have to do two times go to. The first time go to will lead you to some set of states. Okay, so I will be writing all those set of states, and then you have to do next time go to. Okay, so two times go to you have to do, so maybe I will be writing those all set of states. Okay, after first time what is happening, and then one more time. Okay, so let's just do it. Okay. So this is, this parenthesis. Okay, so basically you will be having this, right? That is all. This is fine. Now this is, again, this is capital S. Because of this dot you will be writing all the productions of S. See, again you have to copy all of this, isn't it? Again you have to copy all of this, because these are the all the productions of S and dot is in front of it. So that is why I'm just copying all of this. Okay. Is this fine? Now they are saying you have to do two times go to. One time go to is this. Now one more time go to you have to do. Okay. Let me know if that is understood, that what we are doing. Now if you do one more time go to, then this dot will be basically shifted here, right? And you will be having this kind of state. And then again the whole S productions you will be writing. So isn't it a self loop? Tell me. Isn't it a self loop? This is opening parenthesis, closing parenthesis. Okay. Left. Okay, that's fine. This kind of parenthesis. So basically it will be a self loop, right? I mean, I can say if you do it one more time, you will be getting the same state. Now, what is the question that they are asking? They're asking number of items here, right? So how many items? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what is the answer here? 8 is answer, right? So answer is 8. So 8 items are here. Is this understood to everyone? That what we are doing? Okay. Now let's just move to the next question, which has been asked again very recently, and now also they're asking about the same kind of things. Okay, I mean the same kind of things. They're asking for the go to. Uh, then contains how many items. Interestingly, if you notice, very recently they have asked these same kind of things in 2019, 21, 22. They're just asking go to closure, go to closure. So do you want to do it, or you can? I mean, do you want me to do it, or you can do it by yourself? Or maybe we can do it one question, right? Because this has been asked very recently, so maybe we can do this question also. Okay, so let's just read it out. What they are saying, if I naught is a set of LR0 items, then go to of this contains exactly how many items. Okay, so maybe I just need to basically find out the closure of I naught. What is I naught? So if you find out the closure, I think this is the same as I naught, right? Because you have nothing more to add. Okay, you have nothing more to add. Okay, so this is I naught, and closure of I naught is same as I naught, isn't it? Let me know if that is fine to you. Is this fine? Okay, now what you need to do, you need to basically have plus on this, right? What if plus comes? Now what you will do, you will be writing, let me go to the next page basically. So you are saying here that I naught is given to you, so something like this, right? I naught is given to you, and then you are just asked that what will happen if plus is coming, right? Go to on plus. So basically the whole grammar, let me write the whole grammar also. Whole grammar is this, right? Let me write it here. So what will happen if plus will come? then you will be shifting this plus s gives s plus dot r, right? And then because of this r, because dot is in front of r, you will be writing all the productions of r, which are dot r cross p dot p, right? And then because of this dot r, you will writing all the productions of r. But since it has already been written, so that's why it is not helping you anywhere. So you will writing all the productions of p also, right? Because of this, right? So this is basically next go to state. I mean, from here you might go here and there. I mean, on capital R you will go to something, on capital P you will go into something, on this opening parenthesis you will go into something, on this id you will go into something. Okay, so there will be multiple states from this, but yeah, this contains how many items? Can you tell me? Again, this is 1 2 3 4 5, right? So 5 is again the answer. It is fine to you? Let me know. Okay, is this fine to you? Okay, okay. So I hope that is fine, right? Now let's just move to the next question. See, this question also has been asked very recently, okay, in GATE 2024. And what they're asking is just, don't worry about this SLR parser and all. Okay, we will just see this. They're asking the same thing. Have the closure number of items in the go to set. Do you want to try this question? Do you think this question is hard? See, they're asking easy questions from the compiler. So that is why compiler is actually comparatively, you can say, very scoring. Okay, because generally they ask easy questions from compiler. Okay. So let's just first find out the closure. Closure means basically I will be basically writing dot in front of I think all the, so if you have dot in here, then dot will be in front of every s productions, and because this is dot a and the dot b, so here also. Okay, so I think there will be dot in front of every production from the grammar. Okay, so let me do one thing. Let me copy this grammar on the next page. Let me copy this grammar on the next page, and let's just do one thing. Let's just basically see that what is the closure of this given production, and then we will be basically, if you see the closure, and then we will be basically going from here on the capital S, where to go, right? So see here, go to move on the capital S, right? So on the capital S, you will be going to basically this dot will in the between, and there is nowhere capital S. So basically almost the same state. So it will be S dash, S dash, S dot, and then S gives S dot S. Because of this dot S, you will be writing all the productions of S again, and then you will be writing all the productions of A again, because when you will be writing all the productions of S, there will be dot A. When you will be writing all the productions of this, there will be dot B. So basically you will be writing all of this. All the productions of S, all the productions of A, all the productions of B. Okay. So these, if you notice, these kind of pattern, okay, pattern type of question they're asking since so many days, right? Since so many years. So what is the answer here? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 5, 6, 7, 8, 9. Okay, 9. So 9 is answer here. And they've asked the similar kind of questions in recent years. Okay, they've asked similar kind of questions in recent years. Okay, sorry, 8 or 9? 1, 2, 3, 4, 5, 6, 7, 8. I think the answer is 9. Maybe we have missed one production. Can you quickly check it? Which one we have missed? Okay, one of the production, which is this S gives S as itself, right? I mean, because of this, all the productions of S will come, but I missed one of this. Okay, so total 9 actually, because answer was 9. I remember the answer, so maybe subconsciously I counted it as 9. But yeah, all the productions of S we have to write. It's easy question only, right? All the productions of S. Yes, we just missed out that one production, but now it is fine. Okay, great. Understood. So what we are doing, basically we are just having the closure that okay, where to go, like this, right? Now how to make all of this to parse, or how to use all of this to parse, we will see. Okay, we will see that how to use all of this to parse. Now let's just see few examples. Okay, now I have few examples here, and in these few examples I will just show you that how parsing is working, or how we are drawing the automaton, right? So these are the easy examples only. Let's just do it, and then we will be solving more gate PYQs. You might have noticed that using the simple concept, right, using the simple concept, there has been many gate PYQs that they have asked. Okay, and that is actually a very simple concept. Now we will see more about bottom up parsers. Okay, so let's just continue. So here we have one grammar, okay, which is given to you. Now we will be drawing the automaton of this grammar, right? So for example, let me just try it. So first, what you can do, you can have the augmented production. Okay, so what is the augmented production? This is augmented production, right? And then you will be writing all the productions of E. Then you will be writing all the productions of E. Okay, so you will say this is your closure, or this is closed item or something like that, right? I mean, this item set, state, or whatever you like to call it. Okay, now if capital E comes, then you will be going to certain state. If ID comes, then it is very, very easy. It will be capital E gives ID dot. Okay, if capital E comes, then it will be capital E dash gives E dot dollar, and then capital E gives E dot plus this, right? Now this is the only closure that we have here as of now. Why? Because dot is not in front of any capital symbol. Dot is in front of a small symbol only. Okay, dot is in front of a small symbol only, so that's fine. Now if dollar comes, then anyway it is very easy, right? I mean, it will be capital E dash E dollar. Okay, now if this plus comes, and then bracket comes, basically plus comes, and then whatever it is, then bracket comes. So basically on the plus and bracket, it will be E gives E dot E plus bracket dot E. Okay, I mean, plus if plus comes, the dot will be shifted here, but it is not having more than one production, so I have actually not write it, but you can write it. Okay, and then if open parenthesis comes, then it will be something like this. But because of this dot E, there will be much more production, so maybe I can just draw it on the next page. Okay, so are you getting little bit that what I'm trying to say? Maybe just draw it on the next page. So basically I already have this, that is why I'm just directly drawing it. Okay, so you can notice if capital E comes, it will be going here, it's easy only. And then if dollar comes, it is very easy. And then if plus comes, and then if open parenthesis come, we have come to here, right? And then again, if capital E comes, then you will be going here, because this dot will be shifted like this, and so on, right? So basically I have also numbered them. Okay, if you want, you cannot number, you just skip numbering for now, but let's just number them also. Okay, you can just number them. Is this automated drawing is fine, because this is very important to solve any of the question. Should I do it from beginning, or this is fine that how we are doing it? It is because if you don't understand this, you will not be able to solve questions. Okay, so that's why I'm asking, is this automated drawing is fine? Okay, someone is asking, sir, what is the difference between item and set? Item is just one item. Okay, this is one item. This is called LR0 item. These are called LR0 item. This whole thing is called set. Okay, I mean, you can just call it set, or you can call it item set, because this is a set of items. Okay, you can call it state also. Okay, because this is the automaton, and that's why we call it automaton state. Okay, great. See, you should be practicing this. Okay, that's easy only. I mean, if capital E comes, then where to go like this, right? So this is called automaton. That is called LR0 automaton. Okay, LR0 automaton. LR0 automaton. Now there is something called LR0 table and SLR1 table. So let's just see how to draw or how to make LR0 and SLR1 table using this automata. See, the table is kind of superset of this automata. Whatever automata has, okay, the table will be almost having the same thing but extra things also. So what do I mean by that? Let me just tell you. So we will be basically drawing some table, right? So there will be some rows, okay, and there will be some columns. Maybe I can do one thing. I can just draw row and columns directly like this. Okay, so here how many states you have? Can you tell me how many states you have? Total number of states are 7, right? So 7 states we have, or total number of items we have are item states or whatever, I mean item sets, you have 7. So basically you can do one thing. You can say this is, you can call them I0, I0, I1, I2 like this, right? So you can have 7, or maybe sorry, from I0 to I7 it will be 8. So it is I0, I1, I2, I3, I4, I5, I6 and I7, right? These are the 8 items you have. Okay, I mean set of items. Basically this is a set of items. This is not one item, this is a set of items. Okay, so these are the 8 set of items you have. Is this fine? This is 1, 2, 3, 4, 5, 6, 7, 8, right? Okay. Now, if you are in I naught and if capital A comes, so basically you can also write down small and capital symbols here. Small symbols first. So what are the small symbols? You have plus, opening, closing parenthesis, right? ID. So you have plus, opening, closing parenthesis, you have ID, and you have dollar, right? These are the small symbols. And on the capital, you have just E. This is the capital symbol. Okay. Now suppose you are in I naught. Suppose you are in I naught. If capital E comes, then you will be going to I1. So you just write 1 here. Okay. Or maybe you can write I1. Doesn't matter. Okay. So you are writing 1 here. Now suppose you are in I naught and if ID comes, then you will go to state 3. Right. Basically this ID is called shift move. I mean you will be shifting. Okay. So you will be shifting on the ID. So that is why you will say, if you are in I naught, maybe I can just, do you want me to have both the pictures at the same place, because it is actually big, so it might not be possible, but let me just try it. Okay, suppose you are in I naught. Okay, suppose you are in I naught and if ID comes, you will be going to 3, right? So you will be writing, if ID comes, then you will be going to 3, which is called shift 3, S3. S3 means that you will be going to, you will be shifting and you will be going to 3. Okay, you will be shifting and you will be going to 3. This is called S3. Is this fine? S3 means shift, and I mean you will be shifting on ID and you are going to state 3. And here you are only going to state 3. You are not shifting. Basically on capital symbols we don't say it is shift. Okay. On capital symbols we just say okay, we are going to state. Here we are doing two things. Here we are shifting and we are going to state also. Okay. These are the two things captured here. It is only doing one thing. It is not shift. It is not a shift move. Anyway, you will get to understand. So basically on I1, so on I naught everything is done. On I1 there are how many arrows? 2 arrows, right? So there will be 2 entries on I1. In this line there will be 2 entries. On plus you are going to 4. On plus it is S4. And on cap, or on dollar you are going to 2. On dollar you are going to 2, right? 2, actually you can write 2, or it is generally accept state. This is basically where you have, you have seen everything, you have even seen the dollar. This is called accept state. So you can write 2 or you can write accept state, doesn't matter. So here on dollar you can write accept. Okay, is this fine to everyone? Now what you need to do on 2, on I2, basically you are saying that on I2, okay, there is no move, right? On this, since this is accept state, there is no move. On I3 you are saying that This is I3. You are saying that okay, there is no outgoing move. There is no outgoing move. So that is why there is no entry in I3 also. There won't be any entry in I3 also, right? As of now, okay. And then on I4, if you notice, there is only one outgoing move, which is this. So you are going to 5. Okay. So on opening parenthesis, you are going to 5, which is shift 5. Understood? And then on I5, you are going to, if this is 5, where is 5? This is 5, right? You are going to, on capital E, you are going to 6, and on ID, you are going to S3. So on ID, you are going to S3. On capital E, you are going to 6. So these are the two moves here. On I6, if you notice, then on I6, if you notice, on plus you are going to 4, I4. On plus you are going to 4, so S4. And what else? On closing parenthesis also, you are going somewhere. On the closing parenthesis to this state, right? What is this state number? I think this is 7. Okay. On closing parenthesis, you are going to S7. And what else? That's all, right? And on I7, you are not going anywhere. So this is called LR0 parsing table. How to draw it? Once you draw the automaton, you have to first write all the items here, all the states here, and then all the non-terminals and all the terminals here. First you write all the terminals, including dollar, and then you write all the non-terminals, right? And you just have to mimic it. Okay, where are you going? Here, if it is a small symbol, if it is terminal, you also have to write S. S means you are shifting, and then you are actually doing two things. You are shifting also, and then you are basically moving, or you are changing the state also. Okay, you are shifting also, and then you are changing the state also. So that's why two things should be there. Sixth state is confusing. Why? Because on capital E, see here, on capital E, you will be basically shifting this dot, right? If you shift this dot, then it will be E plus, just a second. If it is capital E, and there will be dot here, E dot, yeah, that is there. E dot is there. So this is one of the state, and then this is an. So dot is actually, I think, not visible, but let me just use another color. There is one dot here. There is one dot here. Okay, so that is why maybe the confusion is coming. So basically, this E will get shifted. So this dot will get shifted here. So this is one state, one item. This dot will get shifted here. So this is another item. Okay, these are the two dots we have here. Okay, so basically you have your automaton, and after the automaton, you should know how to draw the parsing table. Don't worry, we will be having more practice, but if you have doubt as of now, you can just let me know. But it is actually easy. Okay, you just have to mimic it. I mean, you just write all the terminals, all the non-terminals, and you also write dollar. Okay, and then just see that, okay, on I note, where are you going? Okay, if this is a small symbol, you also write shift. Okay, these are called shift entries. These, I mean, here you have shift entries also, right? These are just go to entries. Okay, you're just changing the state here. You will get to understand why that is so. Okay, actually you're not shifting this E, you're just saying that, okay, let me change the state. You will get to understand this later on more clearly. Okay, in just 1 hour you will get to understand this more clearly, that what do I mean by that. So basically, finally you have your LR0 parsing table, right? I mean, not exactly, but yeah, this is actually not exactly parsing table. There is some entries missing, which are reduce entries. So maybe I can just write the reduce entries also, and then I will be finally saying that, okay, this is LR0 parsing table. Okay. So what are the reduce entries? Reduce entry means that wherever you have dot at the end, this is called reduce entry. In this state, there is a reduce entry. Is there any dot at the end in this state? In this state, there is no dot at the end. In this state, there is no dot at the end. In this state, there is no dot at the end. In this state, there is no dot at the end. Yes, in this state, there is dot at the end. Don't worry about the accept state. Okay, for the accept state, don't worry about it. Yeah, so I think there are how many states where the dotted is at the end? There are two states, right? I3 and I7. So let's just number the productions also. So I have numbered them. It is one production number 1 and production number 2. So in I3, there is a reduction. This is called reduction. Okay, dot at the end is called reduction. Reduction of production number 2. So basically, you will be writing on I3. You will be writing R2 everywhere here, which means you will be reducing. You will be reducing. If you are in I3, if you are here, then you will be reducing. Reducing to what? You reducing using the production number 2. Okay, using the production number 2, you will be reducing. So that's why you will be writing R2 everywhere. Okay, and similarly in I7 also, there is a reduction, right? But reduction is basically using the R1. So in I7 also there is a reduction. So R1 everywhere. So now this is the LR0 parsing table. So what do I mean? That ultimately you will be having one table, okay, where you have all the shift entries and all the reduce entries, which is called LR0 parsing table, and which looks like this. Is this fine? How we are making it? Let me again tell you. It's easy only. Okay. For I note, you just check where to go. Okay. For every of this, you just check where to go. Okay. For I note, I1, I3, these are I only. I note, I1, I2, I3, like this, right? Just check where to go. Okay. So once you get to know that, okay, if this is a small symbol, that let's suppose you are going to 3. If this is a small symbol, also write along with this, also write S. So basically, if you are not writing reduce entries, if you are, let's suppose, till this point, okay, till this point it is same as automaton. Till this point it is same as automaton. Okay, I mean here you have just mimic or you have just copied the automaton here. Okay, this is like copying the automaton. You just copied the automaton, right? So copied the whole automaton. Is this fine? Now we will be writing reduce move also. Okay, to infer that what to, I mean, when to reduce. So the whole automata you just have to copy in this format, and then you will be writing the reduce move also. Okay, so where is the reduce move? Reduce move is in 3 and 7. So in 3 there is a reduce, so RR will come, or reduce. In 7 also RR will come. Now it is reducing using this production, which is production number 2. So that is why R2. It is reducing using production number 1. That's why R1. Okay. So it is reducing using production number 2. It is reducing using production number like this. Is this fine to everyone? Let me know. Okay. So this whole thing is actually, if you have a reduce move also, this whole thing is actually LR0 parsing table. Okay. So how to make use of this parsing table? I mean, to parse it, we will just see it. I mean, that's also easy. But first, just understand how to make the parsing table. How to use, we will just tell you. Okay. How to use, I will just tell you later on. I mean, today only. But how to make, this is important. Because many questions have been asked on this only. If you know how to make, then you can solve 99% of questions if you know how to make. Okay. How to use it for parsing, that is not much asked, but you should know. So I will tell you how to use it, because if you are making it and you don't know how to use it, then there is no use of making it, right? Okay, now maybe we can tell you about SLR1 parsing table here only, because SLR1 and LR0 parsing tables are almost same. So, or maybe I can just tell you after a few examples. Maybe let me just have few more examples, and then I will just tell you SLR1 also. So let's just do it for this grammar. Okay, let's do everything for this grammar, which means draw, automata, and make parsing table. Okay, let's just do for this grammar also, right? So now let's just start. How to draw the automata? Can you tell me? You first have the augmented production. What is that augmented production? It will be s dash gives dot s, now which is dot bb, which is, you can have dollar also, which is dot ab. This is your first, you can say, item, right? Or for first state, okay, or the initial state. This is your initial state. Now, what you need to do? Now you basically have capital S. On capital S, it will be going somewhere like this. That's very easy, right? Now you will be having capital B. On capital B, it will be going something like this. Okay. And since there is a dot in front of capital B, that is why all the productions of capital B will also be written. Is this fine to everyone? Now you will be writing, okay, or you will be making the state for small a also. So what will the state for small a? It will be something like this, right? Because there is a dot in front of capital B, you will be writing all the productions of capital B also. Okay, is this fine? Now on dollar, you will be anyway going, okay, to some place. Let's suppose this is on dollar. It is easy. On capital B, here it is also easy, right? On small b, where will you go? On small b here. This is also easy, right? And what else? On small a, you will be going to a dot b, right? This will be shifted. You might notice that on small a, okay, on small a, basically you will be going to a place like this. I mean, it will be same as this. Is this fine to you? Okay, on small a, you will be going somewhere here. Let me know if that is fine. Okay, so everything is done here for this particular thing. Now let's just check. On capital B, you will be going to some state which is looking like this, which is easy one only, right? On small b here, interestingly, you will be going to the same state, this particular state basically, right? Now, I think only one transaction is left, or one go to is left, which is on small a. On small a, basically it will be a dot b, which will be same as this. Okay, on small a, you will be going to somewhere here. So if you like, I can even number from 0. So it is state number 0, and then maybe it is state number 1, it is state number 2, right? And then this is, let's suppose, 3, this is 4, this is, let's suppose, 5, this is 6, this is 7. Okay, is this fine to you? Let me know. Is this understood? Okay. So basically you have gotten this automata, right? Now what you want to do, you want to basically make ultimately LR0 parsing table. Okay. So what you need to do, you can just basically say that we can draw LR0 parsing table, or we can make LR0 parsing table using the automata easily, right? How? Let me just tell you. So these are the seven, again 8 states, right? Again 8 states. So maybe I can basically, you know, draw this table. Okay, how many states there are? This is 0, 1, 2, 3, 4, 5, 6, 7. Okay, how many small symbols do you have? A, B and dollar, right? A, B and dollar. How many capital symbols you have? Maybe I can just little bit shift it. Yeah, so how many capital symbols you have? You have capital S, capital B, right? Okay, so we have capital S and capital B, two symbols. Is this fine to you? Let me know. Okay, now very easily we can make the parsing table also. On I0, there is only one shift. I mean, at A it is going to 4, right? So on A it is going to 4. On capital S it is going to 1. On capital B it is going to 3. Is this fine to everyone? Let's go to I1. On dollar it is going to something which is actually accept, okay? On dollar you can write 2 also, doesn't matter, but it is actually accept state. Okay. On 2 there is, since it is accept state, there is no move. On 3 where are you going? You are going on capital B, you are going to 5. On capital B you are going to 5, right? On small a you are going to S4. On small b you are going to S6. On small b, so it is S4 and S6. Is this fine? And state 4 is also doing the same thing. On small a it is going to S4, and on small b it is going to S6, right? And on capital B it is going to 7, right? And 5 there is no go to, I mean there is no outgoing move. On 6 there is no outgoing move. On 7 also there is no outgoing move. So this is the partial table. I mean only you have only copied the automaton, right? I mean till now you have only copied automaton, right? Now what you need to do now? What you need to do? You basically now have to write the reduce moves. Can you tell me where are the reduce entries? With the dot at the last? Just tell me the reduce entries. Okay. So it is here 5, 6, 7. At 3 places there are reduce entries. Okay. So let me even number the productions. Okay. Let me even number the productions. At 5, 6, 7 there will be reduce entries. So I will be writing R. Okay. And 5 also. 6 also, 7 also. Let's suppose this is production number 1. This is 2 and 3. Okay. So this is the production number 1 reduce, right? So R1, R1 everywhere. This is production number 3. So R3, R3 everywhere. This is production number 2. So R2, R2 everywhere. Okay. So this is your LR0 parsing table completed. Let me know if that is fine. Okay. Fine, right? So how to make this table is very easy. Just make the automata and then copy the automata in the tabular format and then write the reduce move also. Okay. So that you can capture everything. Okay. You can capture everything, that where are the reduce moves. Got it. Let me know if that is fine. Now we can move to the different example. Okay. And then we can try writing the automata, try drawing the automata and so on. But before that, let me also tell you how to make, given this LR0 parsing table, how to make SLR1 parsing table also. Okay. So suppose that for this grammar, okay, for this particular grammar, we have drawn the LR0 automata and all. I mean, this is LR0 automata only. Like we call it LR0 by whether I'm using SLR1 or LR0, we call it LR0 only. So basically, we know how to draw this automata, right? Now, given this automata, we can just copy all of this into the parsing table. So basically, we know how to make this parsing table. Now let's just see, given this automata, how to make SLR1 parsing table also. So SLR1 parsing table. Now I am writing the SLR1 parsing table instead of LR0. LR0 parsing table is done. This was the LR0. Now let me write SLR1. So basically, it is SLR1, right? It was LR0. Understood? So how to do it? Here the difference will be only in the reduce moves. Okay. So in the sense that everything is same, only the reduce moves will be changed. Only the reduce move will be changed. I mean the shift entries and everything will be same. Only the reduce entry will be changed. Okay. So so see, this is our automaton, right? So let me copy the automaton. Let me draw the automaton on the same page. Maybe I can just little bit, I can just narrow it down. Okay. Now you just see here that earlier we were having reducing 3 and 3 and 7 blindly. I mean blindly in the sense everywhere I was writing R2. Now in 3 and 7, in fact there are reduced entries. Okay, I mean the dot at the end here, dot at the end here, right? The reduced entries in 3 and 7. So actually let me write 3 separately. It looks like this. 7 looks like this. Okay. Now what we need to do, we basically need to put the reduced entries in 3 and 7 only, but not blindly. Okay, earlier I said since this is production number 1, so I and this is production number 2, so I said R2 everywhere. I said R2, 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 which means LR0 doesn't look anything. It says that if this is the actually next input symbol, okay, if this next input symbol, if you are in, so basically it says that if you are in state 3, then it doesn't look at the next input symbol. I mean, it doesn't look at whether it is the next input symbol is plus, next input symbol is this, I mean, whatever is the next input symbol. If you're in state 3, reduce it. Okay, if you somehow reaching to the state 3, then reduce it directly to E. I mean, it doesn't look anything. Okay, these are the next input symbols. Okay, so it doesn't look at the next input symbol. This is the LR0. But SLR1 says, I will not do it blindly. I mean, I will not write R2 everywhere. I will reduce only if the next input, this is the next input symbol, that is in the follow of capital E. So what is the follow of capital E? Follow of capital E is anyway dollar, right? So follow of capital E is plus closing parenthesis and dollar, right? Plus closing parenthesis dollar. So it will write only in the follow of capital E. Okay. So basically R2 will be there. R2 you will reducing, right? But plus closing parenthesis and dollar. So the difference is that in LR0 we are writing R2 everywhere. Okay, R2 everywhere blindly. But these two R2 entries will not be there in SLR1. SLR1 will be saying I will be reducing. See, if you're in state 3, then I will be reducing only if this next input symbol, these are the next input symbols, okay, is in the follow of capital E. In the to whatever I'm reducing, if it is that in the follow of capital E, then only I will be reducing. Okay. So it is like that you are parsing, okay, you are parsing some string, and then you get to know, okay, maybe let's suppose this is ID, and then let's suppose next input symbol is something like this. Okay, suppose this is ID. If next input symbol is let's suppose in this case okay, this is this. Okay, I mean this is, let's suppose, closing parenthesis, right? So if you're having this ID, SLR says that I will reduce this ID to capital E only if the next input symbol, which is this, right, is in the follow of capital E. Then only it makes sense. So the follow of capital E contains, then it can reduce. Okay, let's suppose the follow of capital E doesn't contain it. Okay, let's suppose it is ID and then opening parenthesis. Okay, somehow it is ID and then opening parenthesis. Then SLR will not reduce. SLR1 will not reduce this to capital E, because of after reducing whatever I'm getting, the next input symbol should be in the follow of capital E. Okay. So basically the difference in LR0 you will be writing reduced symbols everywhere. Okay, in LR0 you will be writing reduced symbols everywhere, but in SLR you will be writing reduced symbols choosily. So in state 7 you will be writing reduced symbol here also, but in LR0 R1 everywhere, but here only in the follow of capital E. So R1 you will be anyway writing, but only in the follow of capital E. Okay. So what is the difference between this and this? So see here, if the follow of capital E is plus closing parenthesis and dollar plus closing parenthesis and dollar, so you will not be writing, okay, this R1 R2 here and here. I mean SLR1 there are less reduced entries than LR0. Okay, so SLR1 has less reduced entries. That's the only difference. Okay, that's the only difference. Is this a little bit understood that what I'm trying to say? Let me know. So basically, you will say that if you're drawing SLR1, then you will be having less reduced entries compared to LR0. Okay. So maybe we can have more examples, and then you will be getting to understand it more. For example, here we have these, right? I mean, we have basically this whole automata, right? And then we have these entries, LR0 parsing table. Now let's just make SLR1 parsing table. Okay. So these are the three, you can say, these are the three reduce states where the reduce entries are there. So let's just make the SLR1 parsing table. So these are the three states where the reduce entries are there. Now you will not be writing this reduce blindly. Okay, you will be writing based on the follow. To whatever you are reducing, the next input symbol should be in the follow of that. Why? Because then only it will make sense. Okay. So you're reducing to capital S. So can you first tell me the follow of capital S? Then only we can solve, right? So follow of capital S and follow of capital B. Just tell me quickly. Follow of capital S and follow of capital B. So what is the follow of capital S? A, B and dollar. Sorry, follow of capital B is A, B and dollar, right? And follow of capital S is, I think, only dollar. Okay. So in this state, if you're reducing to S, you will be reducing to S is basically R1. So earlier it was R1 everywhere. So if you notice, earlier it was R1 everywhere, right? Now you will not be writing R1 everywhere. You will be saying, I will be writing R1 only in the follow of capital S. So I'll be writing R1 only at one place. Okay. Now here this is R3. Earlier it was R3 everywhere, but you will be writing R3 in the follow of capital B only. So what is the follow of capital B? A, B and dollar. Okay. So it is anyway at every place, but yeah, based on the follow only. Now here earlier it was, this is basically R2. Earlier R2 was everywhere. Okay. R2 was everywhere. Okay. Earlier R2 was everywhere. Now you will be writing this R2 in the follow of capital B only. So follow of capital B actually AB dollar only. So it will not matter. But yeah, but I'm writing based on the follow. Okay. So see, this is the difference that got created. Earlier we were having R1 at both the places. Now we are not having R1, right? Earlier this was R1. Is this a little bit understood? That's what I'm trying to say. Let me know. Okay. So once you tell me if this is understood, then only we can proceed further. Okay. Great. So so basically the difference here is coming that whenever you are writing the reduce entries, okay, in LR0 you will be writing the, see the difference only in the reduce entries first, and the difference will be that whenever you are writing reduce entries in LR0 you are writing reduce entries blindly, wherever it is reduced you will be writing reduce entries. In SLR1 you will be writing reduce entries only in the follow of S, follow of B, follow of B, like that, right? Maybe we can do more examples and then you will be 100% cluster clear about it. That's what I'm trying to say. So let's just do more examples. Suppose we have this particular grammar. Let me quickly make the augmented production and let's just make the automata of this. Now, what you need to do on capital S, you will be going to somewhere like this. And on dollar, you will be going to the accept state, right? I mean, which is as dollar. You can directly write accept or something. Okay. On a small a, you will be going to somewhere. On a small b, also you will be going to somewhere. On a small b, you will be going to S, capital S gives a dot capital S a, and then because of this, you will be writing all the productions of capital S, right? On a small b, on a small b, again you will be going to something like this. And because of this, you will be writing all the productions of capital S. Okay, great. Now, let's just write more more states. So we anyway have to do it. Let's just do step by step. On small a, where will you go? Can you say it is a self loop on small a? So it will be a self loop on the small a. Similarly, I think here also will it be no on a small b there will be self loop. On a small a, here on a small a there will be this transaction, right? I mean it will be going to this. On a small a it will be going to this. Okay. And similarly, on a small b, maybe I can do it step by step, but yeah, I hope you understood. On a small b, it will go to this. I mean, these are like symmetric kind of states. Okay. On a small a, it will go to this. On a small b, it will go to this. Right. This is fine. And what else is remaining? On a small a, that is done. On a small b, that is done. Okay. Then on a small c, it will go to very easy state, which is um, let me make that state here. On a small c, it will s gives c dot, right? On a small c. And it will also go to the same state on a small c. Is this fine? Okay. Now what else is remaining? I think let's just do it for capital S. For capital S, it will go to some state where that's very easy. I mean, it will shift and on capital A or on a small a, it will again shift. I mean, there is no closure. I mean, it will be just one item. Okay, so it will be just one item. Similarly, on capital S, it will be going to somewhere, and and then on a small b, it will go to somewhere. I mean, it will be just one item. Okay, so if you want, I can make it, but that's fine. It will be just one item. Okay, is this okay if I'm just writing like this? It will just one item, right? On a, because it will just dot shift. Okay, dot will get shifted on a small s, on capital S, and then dot will get shifted again. Okay, so if you want, I can write those, but that's fine. Capital S gives a dot as dot a, and then here capital S gives as a dot. Great. Now this is your automaton. Okay, maybe I can just now draw or now make the parsing table. So I'm using this automaton. I have actually I already have the automaton with me. So maybe there I have numbers also. So I can use the same number. So this is the automaton that we have just drawn. Okay, this is the same automaton that we have just drawn. Okay, I mean here I'm not written this, but here I have written on capital S also on. I mean these. Okay, these things. These four I have not written there, but yeah, now I have written these four also. Okay, these four earlier I have not written, but let's just have the complete automaton. So this is the complete automaton that we have. Now let's just try making the parsing table. Okay, using this automaton. Just again easy only. So maybe I can just write it on the corner, and then we can just make the parsing table. So we can just write the parsing table. How to do it? You can just say that this is basically um 0 to 9, right? 0 to 9. Okay, these are the 10 states you have. 0 1 2 3 4 5 6 7 8. Let me draw it. And 9. Okay, So these are the 10 states you have. And then you have um, small symbols which are A, B, and dollar, I think, right? These are only the three small symbols here. Or there are anything else? So A, B, C, and dollar, right? A, B, C, and dollar. Okay. So A, B, C, and dollar. These are the four small symbols. There's only one capital symbol. Okay. Now, can you fill this, or there will be any problem in filling? So, can I quickly fill it? Okay. So it will be S3, S3, S4, and S5. You can just check it. Okay. And then this is accept state. This is S3 from this 3, S3, S4, S5 only. And then 4 also having the same thing, S3, S4, S5 only. And then 5 doesn't have any shift move. And 3 and 4 also have, this is 1, this is 9, 6. These, they also have the, these, I mean, on the capital symbol, they will be changing the states. Okay. On 6, on 6, this is S7. On 9, this is S8. Okay. So all entries are done except the reduce entries. Now we will be making the reduce entries. Okay. For the reduce entries, let's just first check that which states are having the reduce entries. So if you notice 5, 7, and 8. Okay. So which means this state, where is the 5? This state is having reduce entries. 7, this state, and this state. 3 states are having reduce entries. So either 5 or 7 or 8. So if you number them, this is 1, 2, 3, right? So 5 is having R3. So you can write R3 directly for LR0. For LR0, R3 directly, right? So let me just tell you. For LR0, if you want to make this for LR0, then write R3 directly. R3, R3, R3. Okay. In 7 or, sorry, 5, 7, 8, right? In 7, yeah. In 7, you can write R2 everywhere. This is R2. In 8, this is R1. Okay. So you can write R1 everywhere. This is LR0. Now, if you want to make the same table, but this time you want to make for the SLR1, what you need to do? You basically have to write based on the follow. Okay. So what is the follow of S? This is A, B, and dollar, right? This is A, B, and dollar. Follow of S is A, B, and dollar. Okay. Now, just tell me, if you have this, if you are in state 5, then where will you be writing this? See, earlier you were writing everywhere, but instead of C, you will not be writing actually the same table will be there, but R3 will be at only 2 places. Okay. Similarly, it was at 3 places, so it will be only at 2 places, R2. Similarly, earlier it was at 3 places, but now it is only at 2 places, R1, R1. Okay. So this is your SLR1 parsing table. Sorry, dollar will also be there. So A, B, and dollar, right? R3, R2, and R1. Dollar will also be there here. Understood? So that's how we are making LR0 and SLR1 parsing tables. Okay. Let me know if that is fine. So basically now you know that how to make LR0 parsing table and how to make SLR1 parsing table. Okay. Now maybe we can do some example where some of the grammars, okay, from the parsing table you will infer that some of the grammars are LR0, some of the grammars are SLR1, like that, right? So basically, if I just ask you this question to you, that given this grammar, is this grammar is LR0, is this grammar LR1 or like that, right? Then let's just see if you can answer this question. Okay. So what we need to do, we basically need to draw the automaton, right? So, and from the automaton, we can infer whether this is LR0, SLR1 or not. Okay, like that we can infer from the automaton. Okay, so maybe I can just draw the automaton. So start from H dash. Or maybe if you want, I can just copy paste the automaton that I already have. So I hope that will be fine if I just copy paste the automaton that I already have, right? I mean, it will be the same that I will be making, but for the sake of making use of the time in the better way, so I'm just doing it because that can be done. Okay, let's just remove the unnecessary things. Okay. So this is the automaton that we will be getting. Now you just tell me, where are the reduce moves? Because reduce moves will only be creating the conflict. Now what do I mean by the conflict? See, in the table, if you, let's suppose by chance, if the reduce moves are coming along with the shift moves, then only there is a problem. Okay, if the reduce moves are coming along with the shift moves, then only there will be conflict, and then only there will be a problem. Otherwise there will not be a problem. So now I will just tell you that how to check the grammar as LR0, how to check grammar as SLR1. Okay, but let's just have 5 minutes of break. Okay, so let's just meet at 5 p.m. and then we will just continue that how to check grammar as LR0 and grammar as SLR1. Okay. Hi everyone. Okay. So now let's just continue. So I was saying that now we will solve the questions where they will ask, is this grammar LR0 or is this grammar SLR1, like that, right? So what we need to do, we will be just having the augmented production. Okay, this is the very first step. Okay, so once we have the augmented production, then we can continue further. So tell me, will I be adding any more productions here, or this is fine? See, now here the dot is not in front of any capital, so I think this is fine, right? Now we will be saying that okay, on capital S it will going to the places, okay. On capital, oh sorry, on small a it will be going to the capital S, like this, right? It will be going to this place, okay, something like this. But now you will writing all the productions of capital A, okay. You will writing all the productions of capital A, and then you will writing all the productions of capital B also, okay. You will writing all the productions of capital B also. Now you are getting this, right? Now basically from capital A, given this, from capital A you will going to some place, on capital B you will going to some place, on small c you will go to some place. So basically those places are I'm not exactly interested. Reason being is that is not having any conflict, in the sense that it is just having one state, okay. So for example, it will be going to something like this. It will be going to something like this. A gives b dot b, and then it will is on a small b it will going to a gives b dot, right? Okay, on a small c it will going to b gives c dot, okay. Now see, you don't need to make the table, okay, to check whether it is LR0 or not LR0 or LSLR1 or not, okay. You just see the reduce entries, okay. For example, this is, let's suppose, state number 1, or maybe state number I mean you can start with 1 or 0, doesn't matter, but generally we start with 0, okay. This is 0, this is, let's suppose, this is whatever this is going, this is, let's suppose, 1, and then it will go to on dollar, it will, let's suppose, 2, then let's suppose this is 3, okay, and then this is 4, okay. So this is, let's suppose, 4, this is 5, this is 6, and then there will be the state number 7, okay. So this will be the state number 7. Now you notice the reduce move that is in the state number 7, state number 6, and state number 4. Now since there is no shift along with the reduce move, okay, see, in the previous cases also there was no shift along with the reduce move, in the sense that this is not having any outgoing edge. So that is why in LR0 itself it will be tackled, in the sense that see, in LR0 you will be having one row, okay, one row for I4, right? And you will be saying, we will be writing everywhere, let's suppose this is production number 1, right? This is 2, this is 3, then you will say that everywhere you will be writing an I4, you will be writing R1 because this is R1, and that is fine, because since there is no shift move also, so because on any other there is no outgoing edges, right? Since there is no shift move also, so that is why you will say that even if you write R1 everywhere, it is not an issue. So basically, since along with this there is no shift move, along with this there is no shift move, along with this there is no shift move, so this is LR0 itself. This is LR0. If it is LR0, then automatically this is SLR1. Actually, SLR1 is more powerful. So since it is LR0, then that is why it is SLR1 also. Okay. See, you will get to understand everything very, very nicely. But since this is first example, so it might be a little confusing to you. What I'm trying to say, that here you don't have any shift move, right? If you don't have any shift move, you will not be having a shift, okay, on any small symbol A, B, C, let's suppose whatever this is small symbols are, right? So you will not be having any shift move, okay, that it is going to shift or something. Since only reduce move is there, so there is no conflict here, no conflict here, no conflict here. Actually, all the examples we have seen, there was no shift move, so there was no conflict in all the examples we have seen. Okay, but now let's just have some example where we also have also have some I can say some reduce and shift move in the same state. Okay, let's just have some different examples. Okay, great. Let's just have this example. Okay, let's just make LR0 automaton for this particular string, this particular grammar. Okay, so let's just have this example. Now, they're asking, let's suppose they're asking the same thing. Is this SLR1? Okay. Is this LR0? They're asking, let's suppose the same thing. Now, what you need to do, you will be having the augmented production first, right? Let's suppose this is the augmented production. And actually, I have drawn it, okay? I mean, I just need to fill it, but I have drawn almost all of this, right? Almost all of this I have drawn it because otherwise it will be little difficult to manage, okay? That's why almost all of this I have drawn it. Even further, I have even filled it, okay, because otherwise it will be little difficult in the class to write on the on the pen and paper it is actually comparatively easy, to be honest, but here on the computer screen it becomes a little big, okay, so that's why I have written everything here. Now just notice here, this is having reduce, this is having reduce, these reduce, just a single reduce is fine, okay, if it is having single reduce it is fine. I mean, LR for LR0 there is only reduce. See, for LR0 it will say I2, and let's suppose this is the production number 5, it will say R5 R5 R5, right? I mean, there is no conflict. So this is having reduce, it is fine for LR0. This is also having reduce. Wherever you are having reduce, just check it, okay? This is not having reduce, this is not having any reduce, this is having reduce, this is having reduce. Anywhere else you are having shift and reduce both? uh just check it. Is there any state? So basically this is okay, this is okay, this is okay, this is fine. Okay, so I think this grammar is also not having reduce move, right? I mean, reduce and shift together. This grammar seems to be not having reduce and shift together, isn't it? So if there is a reduce move in this grammar, yeah, in this grammar, if there is a reduce move, then there is only a reduce move, right? There is no shift move. Okay, so basically this grammar is LR0 also. This grammar is SLR1 also. Okay, because along with the reduce, this is just reduce. I mean, there is no shift move along with the reduce. Okay, for this grammar it is basically both. But now let's just see if there is any grammar I have in the example where it is not LR0 but it is SLR1. Okay, so let's just see. I think in the example, okay, maybe we can do gate PYQs. In the gate PYQs, maybe we will be finding such grammars. Okay. Or I can just give you a grammar which is not LR0 but SLR1 example, right? Just give me 1 minute. I will just bring you EG grammar, which is not LR0 but SLR1. I think it could be. Okay, I need to make the example otherwise. Just a second. So basically, do you have any example with you? Anyone? Okay, so I got one grammar. Let's just use this grammar. Okay, so suppose this is the grammar. Okay, and now I want to check whether this grammar is SLR1, whether this grammar is LR0, like that, right? I want to check these things. Okay, so what I will be doing, I will be drawing the automaton for this, right? So let me draw automaton for this. Now let me directly write the automaton, otherwise it will be big automata. So that is why I'm just directly writing the automata. Okay, so this is the automata for this. Just a second. Yeah. Okay, so this is the automata that we have, right? Is this visible, or there is any issue? I mean, if you're not able to visible, or there is any issue, you can just let me know. Okay, I hope that is visible. Now let's just see one state. Let's suppose this is one state. Okay, let's suppose this is one state. Let's just see this state. Do you see in this state there is something called as conflict, in the sense that if you are having LR0 parsing table for I2, then you will be having this reduction. This is the reduction, right? This reduction is, let's suppose, so just a second. The grammar is E gives E plus T and T. Okay, and T. So basically, this reduction is, let's suppose this is production number 1, this is production number 2. So this is R2, right? So you will be writing R2 everywhere. Okay, whether it is plus, whether it is star, whether it is ID, whether it is dollar, you will be writing R2 everywhere. Is this fine to you? So R2 will be written everywhere. Now this this particular for this particular thing you will writing ID everywhere, but because of this dot star, or because of this, this is shift move, right? I mean, before star there is a dot, which means you will be shifting on this dot. So on this star, so basically you will writing shift also, right? You will writing shift to 6, you will writing S6 also. So you will be writing two entries here, right? Two entries in LR0. Are you getting my point? So since you have two entries in LR0, there is a problem, right? There is a problem. The problem is that this is having the conflict. I mean, whenever you are in I2 and whenever a star comes, you will be getting confused whether to shift or to reduce. So that is called shift reduce conflict. Okay, that is called shift reduce conflict. So I hope you're a little bit getting. So basically what I'm trying to say, that if you are having LR0, you will be writing R2 everywhere. Okay. Similarly, just notice this. Maybe you can just notice this I7. Okay. You can just notice this I7. Here you have reduce entry. This is the reduce entry, right? First entry is reduce, and the second entry is shift. So if you have like this, then you will say this reduce entry, you have this R1, right? So you will writing R1 everywhere, but on the star you will writing shift also, which you are S6, right? S6. On the star you will writing 6 also. So that is why in LR0 there is a conflict, but it may not be in LR1, because LR1 will not write reduce blindly. Okay. So for LR1 you need to check only one thing. You need to check that if you are reducing, let's suppose you have the reduce move here, right? Reduce move is basically written only in the fall of capital E here. So what is the fall of capital E? Plus and then dollar. So reduce move will not be written in star, because it will be written. See, if you just ask me how to draw the SLR1 table here, okay, you don't need to draw the whole table. You can just infer from the given automata, from the from the entries which are having the reduce entry, those entries are only, problematic. See, if it is having single reduce, not a problem. It is having, see, this state is having one reduce entry and one shift entry. This state is having one reduce entry and one shift entry, right? This state, okay, this state is fine. I think two states are there. Now, basically, this is I2 and this is I7. If you draw I7 in SLR1 now, okay, SLR1 will say that reduce entry, okay, if you draw, then it will say, see, the plus multiply ID and dollar. So these are the small symbols. So it will say the reduce entry, which is R1, okay, R1 will only be at fall of E. And what are the fall of E? Plus dollar, plus and dollar, right? So R1 will be at plus and dollar. It will not be on these two places. And on star there is a shift, which is S6. So that is why you will say that, okay, this is SLR1, because in SLR1 there is no conflict. Okay, neither in this state, I mean, these are the only two suspicious state, right? So in SLR1 there is no conflict in any of this state. Okay, because SLR1 is saying I will write S6 only at one place, but LR0 will say I will write S6 at multiple places, and that is the problem, right? That is the problem. Okay, so I hope you are getting a little bit. So basically, this is SLR1 for sure, but it is not LR0. Why? See, if you are having in any automata, if you are having A gives alpha dot, which is a reduce entry, along with the reduce entry, okay, if you are having any shift entry here or any reduce entry even, okay, along with this reduce, if anything is here, maybe there's a shift entry, right? B gives small a, then this is not LR1, not LR0 for sure, right? Similarly, if you are having this, and along with this you have anything, maybe this, okay, maybe reduce also, then also let's suppose this is I5, then also in I5 you will say, let's suppose this is production number 5, production number 3, this is production number 7, then you will say R3 everywhere, and R7 also everywhere, right? So that is why there is a conflict. So this is also not LR1, this is also not LR1, so both are not LR1, sorry, LR0, okay, not LR, I mean, not, I'm talking about LR0. This is also not LR0, this is also not LR0. Understood? Let me know if this is little bit fine. So basically, if along with the reduce entry you have any entry, okay, anything, okay, this is anything, then you will say it is not LR0. Now tell me, is this LR0, is this SLR1 or not? Suppose this is given to you. Now you say this. What about SLR1? It will be SLR1 or not, it will depend on, this will go to the follow of A, right? This entry, see, the row is same. I'm only fighting for the column. Okay, row is same. I mean, all the entries will be going to the row of I5. Okay. So let's suppose this is production number 3. So R3 will be everywhere in R0, LR0. Okay. But in SLR1, let's suppose these are the A, B, C, D. Okay, these are the small symbols. Okay. But in SLR1, this R3 will not be everywhere. It will be only in follow of capital A. Right? See, this shift entry is fixed. Let's suppose it is going to I6 or I7, right? At B, it is going to I6. Okay. So the shift entry is fixed. Now the only thing that matter is that the reduce entry is coming to B or not. If the reduce entry is also coming to B, there is a conflict, right? So reduce entry will come only at follow of capital A. So you will say, if follow of capital A intersection this B is phi, then it is, I mean, basically this particular state is not creating any problem. Then you will say it is SLR1, and that has to be true for every other state. Okay, so basically, I mean, it will go into the follow of capital A. B should not be in the follow of capital A, right? See, suppose, okay, whatever, right? And then there is a B, C dot D. So you will say D should not be in, because it will shift on D, but it will reduce on fall of capital A, right? So D should not be in fall of capital A. Okay, if that is true for all other states also, not just for one state, but for all other states also, then you will say then SLR1. So basically, if true for all, okay, something like this. Similarly, I mean, I have to check all the conditions. Similarly, basically, this is going to be interesting. Basically, let me just tell you, if you have two reduced entries, okay, two reduced entries, in that case, you have to make sure. See, the row is fixed, right? You have to make sure that follow of A and follow of B should contain nothing, because it will go to in the follow of A, it will go to in the follow of B, in the sense that row is fixed. Okay, let's suppose row is I5. So follow of A will contain, let's suppose this is R, this is first production, okay, R1, this is the fourth production. Follow of will contain R1. Okay, follow of A contain R1, follow of B will contain R4. Okay, if any of this is overlapping, then R1, R4 will be there and it will be a conflict. If any of this is overlapping. Okay, are you getting it? Let me know. Okay. Now let's just move to the next slide. And before that, I can just make any conclusion if you want. So basically, if you have something like this, right, it is not LR0 for sure, because with the reduced entry you have anything else. Similarly, if let's suppose this is again not LR0 for sure. Okay, these are not LR0, but for SLR1, okay, it is necessary, it is not sufficient, because sufficient I will say if it is satisfying for all the all the states, but I can at least say it is necessary. Okay, necessary is what, that follow of A should not contain B, or maybe in other words, B should not be in follow of A, right? Similarly here, no, for SLR1, basically for SLR1, similarly here, follow of A and B, follow of B should be 5. Okay, is this okay to everyone? Let me know. Okay, great. Now let's just move to the next slide. Now let's just do few PYQs. Okay, let's see this, what they're saying. They are saying that you have this this symbol, and then you have this, the input symbol has, okay, so it will be shifting. Okay, so it will be shifting on this, and will it be reducing? Yes, so there is a reduce move. Now canonical set of items in the given below, they should give it, it should be LR0 or what, right? They have not given it, that they're talking about LR0 or SLR. I mean, they have not even given the complete grammar. Is this the complete question? Let me just check, because they have not given the complete grammar here also. Yes, that is right. So Udit is saying if LR0 is there, so basically let me just clarify it. Okay, so see, these are the LR0. If LR0 is there, then definitely it will be SLR1, right? I mean, SLR1 can parse all the grammars which are parsed by LR0. Okay, but there are certain grammars. This is not LR0, but SLR1. Okay, this is not LR0, but SLR1. Okay, So by the way, in this particular question that we are seeing, this is they're just confusing it. This is closing, parenthesis. This is opening parenthesis. So on the opening parenthesis, they are asking, okay, not on the closing parenthesis. So that's why I was just saying that, okay, what is happening? So on the opening parenthesis, there is neither shift nor reduce. Okay, this was just to play with eyes. Okay, that if we can recognize whether it is opening or closing. Okay, let me know if that is fine. So now let's just move to this question. What they are saying: indicate shift reduce and reduce if any in the various states of LR0 parser. So basically, you need to make the whole automaton, right? So and then in the automaton, you need to indicate whether they are having any. There is any conflict. So maybe I can just do it, or can you do it as an homework? Let me know. So maybe you can do it as an homework. Okay, that's that's not a tough question. If you want, I can also do it. So let me know quickly if you want me to do it, or you can do it as an homework. Okay, so let's just quickly see. So they are saying that just draw it. Okay, so if you draw it, draw the automaton, then let's just see that what is happening. See here if you have noticed, then they have given epsilon. So don't worry about the epsilon. Okay, so let me tell you that what we need to do. So don't worry about the epsilon. It's not going to do any harm. Okay, so this is the grammar which is given, right? Now I think this is s dash. So s dash gives dot s. You can put dollar if you want, otherwise that's okay. Okay, so now this s will give dot ss dot a and then dot only. Okay, I mean dot epsilon or dot is fine. Okay, dot only. Now if capital S comes, it will go to uh, it will go to s gives s dot s, and then because of this s you will writing all the productions of s, right? And if capital S again comes, I think it will be self loop. If capital S again comes, okay, I hope that's fine. And then if small a comes, okay, from here if small a comes, then it will be s gives a dot, right? I hope that is fine. Okay, so what they're asking is indicate shift reduce and reduce conflict. So see here, there is, okay, so you can also write on capital S, you can also write this, okay, and then dollar it will be separate, right? Now they're asking if there is a shift reduce or reduce conflict. So there is only single entry. This is only, okay, so this is a reduce move. See, this dot itself is a reduce move. Okay, this dot itself is a reduce move. So it will get reduced. So they're asking in the LR0. Yes, so there is a conflict here, right? There is a conflict here. Because this itself is a reduce move, right? So similarly, there is a conflict here also, because this is a reduce move, and there is a shift move. Okay, this is a shift move, and there is a reduce move. Okay, so there's a conflict here also. Is this understood? Let me know. Okay, so that's the only answer. This is a very old question, so you just need to make the automaton and just tell if there's a conflict. So they are saying every SLR1 grammar is unambiguous. So basically they can only parse the unambiguous grammar, right? So let's just see this question. This question is not tough. I mean, it is easy question only. And I think you might remember in part 1, I told that, okay, you can parse any string using CYK. There is some algorithm called CYK, right? CYK algorithm. And and that takes cubical time, okay? But you can parse any algorithm using CYK. So let's just read out this question. What they're saying: every SLR1 grammar is unambiguous, but there are certain unambiguous grammars that are not SLR1. So yes, that is true, right? I mean, not everything is SLR1. So that is true. For a context-free grammar, there is a parser that takes at most order of NQ time to parse a string. So this is there is some algorithm called, this is one statement that you need to know. Okay, don't worry about the algorithm. So there is some algorithm called CYK algorithm that can parse any context-free grammar in order of NQ. Okay, so basically this is also true. Okay, both are actually true. So that's why C is the correct answer here. For this second statement, there is a one thing you need to know. Okay, there is some algorithm that exists and that can parse in order of NQ, but we are interested in order of N. That is why we have the parsers like LR0, SLR1. All are order of N. Okay, LR1, all are order of N only. It will not take more than order of N. It is just a linear pass. Okay. Okay, so now we need to basically see how these automatas are working, right? I mean, we have seen that what is this LR0, SLR1, right? But we have not seen that, okay, how this automata makes sense. So this is a small topic only, but it is very, very important that how this automata makes sense. So let's just do this topic in next session because I think this session has been quite long. So is this okay if we do this in the next session? Okay. Or maybe should we do it now only? Tell me immediately. Okay, we can do anything. We can do now, or we can do in some session after 2-3 days. Maybe on 27th, because in between you have AIMTs, right? And then I think it is better if we can cover it in the next session because there are too much to cover. Okay. So is this okay if we can do it in next session, because I think it will take 2 3 2 3 more hours. Let's just do one thing. Maybe we can cover few of this and then we can decide later on. Okay. So basically what I'm saying here is that we have seen the automaton, but we have not seen that how these really works. Okay, how these really works. Okay, really understanding these LR automatas. Okay, there is one topic called rerun of DFA. Let's just understand it. So okay, first let's just understand what is this automaton, right? Suppose this is one automaton that we have here. Now what each of this state is representing. Okay, what each of this state is representing. So this is the automaton that we have for one of the grammar. Okay, earlier. So suppose a small v comes, then I will be going here, right? So basically each of this, suppose I am in this state, then basically each of this state can tell you what is there on the stack. For example, if I am in this state, I must have come into this state only after seeing b. So stack must be containing I mean top of the stack at least. Okay, on a stack top you might be having b, but since you can be in this state after seeing multiple b's also, so basically stack might be having only one b or maybe multiple b's. Okay, so you can say stack, if you are okay, they are asking about state 5. So if they ask about state 4, then the state, if you are in state 4, then the stack must be having. So basically I want to relate that how this automaton and how stack are related. Okay, so suppose you are in this state, then it means that you have seen b and you might have seen multiple b's. So stack might have contained multiple b's. Suppose you are in state 5, this state, then what does this mean? It means you might have seen C only. Okay, what are the ways to come to state 5? Okay, so in stack you might have seen C only. You might have seen, okay, ways to go here basically are multiple. Okay, this way, this way, this way. There are 3 ways, right? So you might have seen C only. You might have seen B and then C, right? Or you might have seen A and then C, right? So basically you might have seen C only, or maybe first B and then C, and then, or maybe A and C. Okay, A and C, right? So basically you can say there are, if you are in state 5, these are the three possibilities. Okay, these are the three possibilities that you will be having, either this or this. So which is correct answer? Or in other words, you can say that if it is C, if it is C dot, it means in state 5 you can come only after seeing the C. It means stack top must be C. Okay, so the top of the stack could be, can it be B B B C? Can you have multiple B's? Yes, we can have multiple B's, right? Since it is MSQ question, because B and then multiple B's, after having multiple B's and then C. Yes, this is correct, right? Yes, this is also correct, because C dot means stack, the top of the stack must be C, right? The stack content could be BC BC. Can it be BC? Okay, you just need to you just need to run this. Okay, BC and then BC. No, right? The stack content could be BSC, B and then S, and no, there is no move on C. So basically, this is also not true. So here you can say A and B are true. Okay, here you can say A and B are true. Is this understood? Let me know. Right? So basically, I'm just saying here that if you are in state 5, then what are the things that are there on the stack? Okay, what are the things that are there or that are possible on the stack? So A and B are the correct answers, because you just need to run this. Okay, you just need to run this. If the transition is possible, then you can say that, okay, using BC you can reach to state 5. Okay, or using directly C you can reach to state 5, or using A and then C you can reach to state 5, right? So that is why A and B are the correct answers. Is this understood? Okay. Okay. Now we will try to understand it slowly. Don't worry. Okay. First, let's just understand what this state mean. Okay. Consider this LRG automata of some unknown grammar. If the parser is given, sorry, if the parser is given in the current state, okay, what can we say about the content of the stack? We will not say anything. We cannot say anything about the content of the stack. The top of the stack must be A. See, I know that after A only, okay, see, this dot is before A, right? The dot is before A. So after A only I have seen this. This is like this, okay? After A only I have seen this. So top of the stack, I just have seen A, right? I mean, before there could be anything, but I just have seen A and I pushed it. Okay, if dot is before A, it means the top of the stack must be A. Okay, top of the stack must be A. Is this fine? Let me know. Right, so that is the only answer here. Top of the stack must be A. It cannot be B, cannot be C, it can we can okay, so basically B is the only answer here. So let's just try to understand this little bit more. Okay, suppose they are saying consider the LR0 item. What can we say about the LR0 items? Suppose these are the three items. Okay, item 1 and 3 could be the part of same state. Can you have in one state, can you have 1 and 3 in one state only? It is not possible. Why? Because here you are saying you will come to this after seeing A, you will come to this after seeing C, right? So in one state, 1 and C combinedly is not possible. Is this fine? So that is why A is false. What about B? 1 and 2 could be part of the same. 1 and 2. Can 1 and 2 could be part of the same LR0 automaton state? No, again no. Because here it is saying top of the stack must be capital B. Okay, see, any of this cannot be part of any single state. Okay, because it is saying top of the stack must be B. Top of stack must be B. We have just seen capital B. Must be. It must be capital B. Okay. So that is why these three, all of these three are wrong, because here these are differing. These are not agreeing on the top of the stack. Okay. So item 3 must belong to different LR0 automaton state. Is this fine? Okay. Maybe I can just ask you to solve this question now. Can you solve this question? Consider this grammar. Consider these three grammars above. Consider these three LR0 items. Okay. What they are saying, given the item below, sorry, given this item above, which two of them will appear in the same state in the canonical set of items? See, here they are saying top of the stack must be this, top of the stack must be this. Which two of them? Tell me. What is the answer here? What is the answer? Just solve this question, okay? Because because this question is nice question, and if you solve this question, then basically the chances are that you must have understood concepts pretty well. So what is the answer? See, they're differing in the top of the stack, right? They're differing in the top of the stack. So basically you will say that none of this, none of these. Okay, none of these. This question has been asked in 2006. This is saying that if we are in this, if we are in some state which is having this item, which is having this item, if you are in some state which is having this item, it might be having multiple items, but if you are in some state which is having this item, it means that top of the stack must be s star, okay, and then dot. Oh, sorry, s star, okay, dot is just to represent. So top of the stack must be this. If you are in this, okay, so this should be the top of the, below this there could be anything, but top of the stack must be this. You have just seen s and you have just seen star, okay, this should be the top of stack. Is this fine? Okay. And if you are in this, I mean, if you are in some state which is having this item, it is saying the top of the stack must be capital F. I mean, below could be anything. Below could be anything, but top of the stack must be capital F. They're differing in the top of the stack itself, right? So this is a basic question, but it is a nice question. Okay, and that is done only when you understand that how the stack and automata are basically related to each other, right? Okay, so there are you know there are two more types of parser which are called LALR and LR1 parsers. So let's just do one thing. Let's just do this LALR or LR1 parser now with examples, and then we will be solving gate PYQs. Okay, so that you will get to understand more about LALR LR parsers before we get into gate PYQs. Okay, so we have seen LR0, we have seen SLR1, right? These two parsers are done. Now let's just see these two parsers also. Okay. So here what we will be doing, earlier we were having just this, I mean we were not having this comma thing. Okay, here what we will be doing, we will be also having this comma something. Why that is the case? Why that is the case, let me tell you. See, let me tell you one example. Okay, in some of the cases that SLR1 might not work. Okay, let me tell you one example. In some of the cases SLR1 might not work, and then we need to go to the higher level of parsers, okay, which are LLR and LR1. Let me tell you why it might not work. Okay, before I jump into this, let me tell you why it might not work. See, suppose you want to parse this string. Okay, suppose you want to parse this string. Now what will happen? You will say C, I mean, you will be basically shifting this bar. You will say, okay, C, A, B, A, right? Now, after seeing the C, is there any reduction possible? I think no. So you will be basically saying that, okay, C, A, B, A, right? Now this A is on the top of the stack, basically. This A can be reduced to capital A. Okay. It will be reduced only when the next symbol is in fall of capital A. Is the next symbol fall of capital A? See, what I'm saying is this small b, is this in the fall of capital A? If that is the case, then SLR1 will reduce it. Okay. So is small b in fall of capital A? Tell me. Just let me know. Okay, just let me know. Yes, right. So since it is in fall of capital A, that is why small a will get reduced to capital A, right? And then if you do it further, small a capital A, see small a capital A and small a makes sense, but small a capital A and small b doesn't make sense. I mean, if you do it further, it will get stuck, and SLR will say that okay, I'm not able to parse it, right? SLR will say that I'm not able to parse it. So what I mean to say, if you do it further, small a, capital A, small b, it will get stuck, right? SLR will say I'm not able to parse it. Are you getting my point? So basically, reducing this to capital A is basically a blunder. Okay, this is a mistake. See, even though B is in fall of capital A, even after you reduce it, next symbol is in fall of capital A. Still this is a mistake. Why? Because you notice one thing here that is very interesting. That next symbol B is in the fall of capital A. That I agree. But here, if you even check, instead of fall of capital A, if you check the fall of small c capital A, the whole stack, okay, follow of whole stack. What is the fall of small c capital A? Fall of small c capital A is small a, right? So basically, if some symbol is there, like for example B, if that symbol is in the fall of stack, then it makes more sense, right? In the, like what I'm saying, that see, that is in the fall of capital B, that is fine, but it might not be in the follow of the whole thing. It should follow the whole thing, right? So in those cases, there is a problem. In those cases, SLR1 fail. Where the cases where that you're reducing by saying that okay, it is in fall of capital A, right? But ultimately, it is not making the whole sense. As a whole, it is not making a sense. I mean, individually, it is making a sense. But if you look at whole stack, it is not making a sense, right? In those cases, SLR1 will fail. Okay. So maybe I can give you more example. For example, this. Okay. Suppose you have this string which is ABA, right? Suppose you want to parse this. What you will do? You will say that okay, ABA. Okay. And then in the fall of capital A, this is B, right? In the fall of capital, there is a B. So you can reduce this small a to capital A. Suppose you reduce this small a to capital A, right? Now, now you notice that isn't it a blunder? I mean, you should have basically pushed AB first. I mean, basically it should be like this. See, I mean, ultimately it should be like this: A B A, and then AB should be, and then AB small a, and then this small a should be capital A, AB capital A, and then this is S, right? So basically, if you're reducing early, if it is early reduction, if you're reducing, then it is a mistake. And why you are able to reduce? Because this small b making sense with capital A. This small b is making sense with capital A. I mean, it is a follow of this capital A. But it is not. See, we should be having this small b should be the follow of small a capital A. I mean, if we are having small a capital A here, then only it will make sense, right? I mean, individually, if you are looking just like this, okay, just like it is makes sense. But as a whole, it is not making sense. Okay, which means that AB doesn't make sense, but yeah, small a AB makes sense. So basically, whenever you're reducing, if we are reducing just by that, okay, the next symbol is in the fall of capital A, then ultimately along with the stack, it might not make sense. That is a problem. Okay, so this is a mistake, and that is why this is not SLR1. Even you can check this. Okay, not SLR1. You can immediately check this, that this is not SLR1. Let's just quickly check this, that this is not SLR1. So that's why we need higher level of parsers. Okay, so maybe I can just do this. Okay, I think this is little big I have made. And then on capital A dot A. Okay. So on small a, it will be capital S A dot AB, right? And then A dot BA, and then A gives dot A. Okay. On capital A, there will not be a problem. On a small a, there will not be a problem. I mean, there will not be a conflict. On a small a, there is only a chance of conflict. Okay. I mean, later on. Okay. So on capital A, this is just a shift. On a small a, I have already taken care. Okay. So on a small a also, there is basically, since on a small a, there is one more, which is A gives A dot. Right. Okay. So see, is this having any conflict? So this is a reduction, right? So there will be a reduce move because of this, and there's a shift move because of this. Now, when is the conflict? Whenever this shift is in the fall of capital A. So this B is in the fall of capital A, right? B is in the fall of capital A. So that is why there is a shift reduce conflict. There is a shift reduce conflict in SLR1, right? This is not SLR1. Actually, it is getting confused. Whenever you are seeing a small a, it is saying reduce it. See, whenever you are seeing a small a, it is saying reduce it, right? But if the next input symbol is B, there is a conflict, right? I mean, it will get confused because it is saying that, okay, if the next input symbol is B, I will reduce it. Okay, if the next input symbol is B, I will reduce it, but I have to also shift it. Okay, so that is why it is not SLR1. If you by chance reduce it, okay, then this is a mistake. So basically the thing here is that not all grammars are SLR1. Okay, you need to have more powerful parsers. Okay, so for that we have LR1 and LALR1. Now how does it work is that earlier we only had this, right? Now it will say we will maintain something called as comma. Let me just tell you that how it works. Okay, so we will be having augmented production first, as usual, but here we will be having comma dollar. Okay, here we will be having comma dollar. So is this a little bit okay what I'm trying to say? That earlier we were not having this, but now we will be having this also. Okay, so what do I mean by that? I will just tell you. Okay, so basically we will be having this kind of state now. Okay, I mean, we will be having with comma. Now you can just write as gives dot a, okay, comma, first of whatever. See, this production is coming because of this line, right? Because of this s, this production is coming. Now comma, first of everything after it, so which is basically dollar only. Okay, first of everything, which is just dollar. Okay, so this is coming because of this. Now because of this a, you need to write all the productions of a, right? And then dot b also. Now both of this is coming because of this a, right? So that is why first of this will come. First of this, what is the first of this? This is a and b, right? So let me write a b like this. Okay, or maybe a comma b, you can write a comma b. This is also coming because of this, so you can write a comma b. So basically you can say that first of this, which means that if these two productions are coming because of this, right, then after the comma, these are called look aheads. After the comma you will be writing first of whatever is remaining. This is very interesting way to maintain the look aheads. So basically it is just differentiating this a and this a. Okay, in the sense it is saying that if ever you reduce to this capital A, okay, if ever you reduce to this capital A, then I will be reducing. Okay, maybe you will not get this line, but I'm just saying it in case if you get it. Okay, so whenever you want to reduce to this capital A, in the sense that if something is going to capital A, right, if something is going to capital A, then you do it only when the next input symbol is small a and small b. Okay, so in the sense that since this capital A makes sense with this only, right? That is why you reduce to this capital A only when the next is the first of this. Okay, slowly you will understand. But let me just make the automata. So let's just first understand step by step that how to make automata. Okay, this is the very first step, that how to make automata. Okay, so I think these are the productions that I will be having in the first initial state, right? Now on capital A you will be going to somewhere, right? What is that? As gives, it will be as gives capital A dot A comma dollar h as it is. Now because you have dot in front of this, you will be writing all the productions of A, all the productions of A. Now because this is, these productions are because of this A, because of this A, that is why comma first of the remaining, right? So comma dollar, comma dollar. Okay. So this will be the state that you will be getting on capital A. What will the state that you will be getting on small a? Capital A, AB, right? And then you will be getting on small a, you will be getting this. Okay. Is this okay to everyone? Now, because of this, you will be writing all the productions of A also. So maybe, uh, let me write it here. Let me write first all the productions of A. Sorry, all the productions of A you need to write, right? So these are the all the productions of A. Now, since we have written all the productions of A because of this, so first of the remaining one, which is AB. Okay. So this is the next state. Now on small b, where should go? A gives b dot AB. Okay. I think, yeah. So for this particular state, for this the very first state, every other transaction is done, right? Every transaction is done. Every transition, not transaction, transition is done, right? Okay. Now let's just check. Let's just check what is going to happen for this on capital A. What is going to happen for this on capital A, right? So it will be very easy. As gives a dot and then dollar. Okay. I mean, you will not be writing any other production. On a small a, what will happen? On a small a, it will be a gives a dot a dollar, and because of this, you will be writing all the productions of capital A. And since you are writing because of this, that is why first of the remaining one, which is the dollar dollar. Okay. Is this fine? Okay. So I think we are done with this. We also need to write on B. B I will write. I will be writing on the B. It is easy one. On the B it is easy. On the B it is easy. Okay. So now let's just check this first. On a small a, where to go? So on a small a, let's just check where to go. On a small a, where to go on this? See here. This will be a dot a comma dollar, and because of this a, all the productions of a will come. All the productions of a will come, right? Sorry, dot a and b. Let me make little space. And since it has come because of this a, so that is why you will write in comma remain first of remaining comma dollar, right? Okay. So if you notice, this state and this state is same. So that is why you can say this is self loop. Okay. You can just directly write the self loop since both of the states are same. You can say this is self loop on this a. Okay. So majorly we are done with everything. I mean, the small things are remaining. That what to do. Okay, here small is remaining. Otherwise, what to do in small b? That's easy. What to do in small b here, because this is just one line. Okay. So maybe I can first tell you what to do on a small a. Where to go on a small a, right? So you just notice it will be a gives comma AB. This will be as it is. Now, because of this, you will be writing all the productions of A, right? You will be writing all the productions of A. So let me write all the productions of A. Since you're writing because of this, that is why, comma, first of the remaining one. So it is AB only, right? Which is AB only. Now you notice this and this are same, right? These two are actually same. So that is why on A, there is also self loop. Because these two are actually same. So that is why on small a, there is a self loop actually. On this particular state also, small a, there is a self loop. Okay. On a small b, it is easy actually. On a small b, if you want, I can just make it. It is easy. On a small b, I think this is easy, right? On a small b, everything is easy. Okay. So this is, I've not drawn fully, but yeah, this is how LR1. This is called LR1 automaton. Okay. This is how LR1 automata will look like. Is this little bit understood that what I'm trying to do? Okay. So basically they are just saying that that after the comma, okay, you just write all the things using which this particular set of productions you have written. Okay. So using this A, or because of this A you have written, so that is why after the comma write first of this. And it actually makes sense. Maybe you might not be getting, because if you are studying this very first time, but it makes sense. Let me just tell you in one line. If you don't get the intuition, it's okay, because that's not required. Okay, but still let me tell you, if you get it, then it is fine. Otherwise, just don't worry about that. Why we are writing the first of this, right? See, we are saying that whenever you want to reduce to this capital A, see, these two capital A's are different for LR1. That's what they are saying. These two capital A are different. They are saying whenever you want to reduce to this capital A, that will be reduced using these productions actually. Okay. So whenever you want to reduce to this capital A, which will be done using these two productions actually. Okay. Then you can reduce, or you should reduce only when the next symbols are basically are this. I mean, they won't come directly. So basically they mean the next symbols are first of this. Next symbols are first of this. Little bit you might have understood, but that's fine. About the intuition, you just need to understand how to make the automaton. Okay. Okay, great. So now let's just do one thing. Let's make the table. Okay, once the automata is ready, the table is actually easy here. Okay, in the table you don't have to calculate the follow and all. You whatever hard work you should be doing, you have already done. So in the table you can just write the reduce entries in the lookheads. So just tell me if there's any reduce entry. So maybe actually I have not drawn the full automaton. Either I can draw the full automaton, or maybe I can just copy the automaton that I have. See, in the full automaton, I think there will be one more state. Here also there will be one more state. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 8 states will be there in total, right? Or maybe more. One or two I might be missing. Yeah. So basically, if you want, I can have on capital S and on dollar. So two more I can have, capital S and dollar, something like this, right? Okay. So I actually have the automaton ready. So maybe I can just write that automaton for you, and then we can just make the table. So this might look little big, but it is the same automaton, okay, that we have just drawn. Okay, so for the table, actually the table is very easy. How to draw the table here? For the table, what you need to do? Let me just put the template of the table, the lines here. See, these are the 0 to 9, right? These are the 10 states actually. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, and then there will be one more, which is, let me just write this, which is 9. Okay. Now, what they are saying, that you are having these 0 to 9, right? And then what are the small symbols here? The small symbols are A, B, and dollar. And the capital symbols are A and S. Okay. Capital symbols are A and S. Now shift moves are very easy. Okay, wherever you are going, just like that, you can just shift it. Okay. So for example, on small a you are going to S4. So on a small a you are going to S4. So you can write S4. On capital, on a small we are going to S3, and then this will be 1 and 2. Okay. And similarly S7, S6, and then this is 9, this is 9, and then this is anyway accept. Okay. On 3 there is nothing. On 4 S4, S3. On 4 this is S4, S3. Okay. And then this is 5. So you can just check. On 4 you are going to S4 itself, and then S3, right? So you can just write the shift moves. It's very easy, and I will just tell you how to write the reduce moves. Okay. So on 7 you are going to, so 7 you are going to 7 itself on A, S7. And then on B, are you going to S6? Yes, S6. And on dollar you are not going anywhere. Okay, here it will be 8. On 8 and 9 you are not going anywhere. Okay, so these are the shift moves as usual. I mean, in the same way you will be writing the shift moves, right? For the reduce moves, what you need to do, first identify where are the reduce moves. Okay, just like the previous one. So in state number 3, if you notice, there is a reduce move which is A gives B dot comma A comma B, right? So if there is a reduce move, this is state 3 or I3. Okay. Then if there is a reduce move, then what you need to do? Earlier we have to write in the follow of capital A, but now you just write here only. Okay. So reduce move, let's suppose this is the production number 3. So you will be writing R3 in small a and small b. R3 here and here. Is this okay to everyone? That what we are trying to do? So if there is a reduce move, then it has to be here only. Okay, that's all. I mean, you don't have to calculate the follow. You just see that, okay, the follow is already written. Okay, you've already calculated the follow like that. Okay, so there is a reduce move in state number 5, for example. Okay, so this is a reduce move in state number 5. This is the reduce move. So this is A gives A dot comma AB, right? So this will be only in AB. Okay, so this is R2. So R2 is only in AB. Similarly, there is a reduce move in state 6 also. For example, this one. Okay, I'm just zooming it out. A gives B dot dollar. Okay, this is state 6. There is a reduce move here, right? Since there is a reduce move, so it will be only in dollar. So it is, let's suppose, the production number 3. Okay, so this will be only in dollar. So it will be only in dollar, R3. Similarly, there is a reduce move in 9, okay, which will be only again in dollar because there is a dollar. So R1 is only in dollar. Similarly, there is a reduce move in 8, which will again be only in dollar. So R2 is only in dollar. So that is how you can make LR1 parsing table. Is this a little bit understood? Is this little bit understood to you guys? Okay. So what we are doing, we are basically saying here that we can make the table just like the SLR1 table. All we need to do is basically reduce moves will be taken care differently, in the sense that earlier it was in the follow, but now it is in the look ahead. This is called look ahead. This is called look ahead. Now it is in the look ahead. That is the only difference. Okay. So this is how we are making the parsing table. Now let's just do more examples. Probably you will get to understand it more. Okay. Probably you will get to understand it more. But before that, I want to tell you that if two items, okay, let's suppose here, let me go to the complete automaton. Let's suppose I have this as complete automaton. If two items are basically having the same core items but different look ahead, then we can merge them. and we can make LALR also. Okay, so for example, if you notice, this 3 and 6, okay, this 3 is a gives b dot ab, this was 3, 6 is a gives b dot dollar, okay, this is 6. So if they're having the same core item, if you notice this core item is same, only this lookahead is different, then we can make from LALR itself, we will be making LR itself, we will be making LALR. How? We will be merging 3 6, okay, to make LALR. How to merge? Let me tell you. So this is 3, right? This is 6. We will be merging the entries of this. So we will be basically having, this is LR1, right? So in the LALR1, we will be having something like this. Let me tell you. So see, let me write side by side. This is LR1. And in LALR1, we will be having this 3 and 6 merged. How? Instead of 3 6 differently, we will be writing 3 6 only. Okay. And then this R3, okay, this R3, you can move to this. And then you can remove this 6. Okay. And now notice that not just 3 and 6, we can merge more also. For example, 4 7. So total that we will be merging, 3 6 are having the same core item and different locats, that's why I have merged it. Similarly, we will be merging 4 7, we have merged 3 6, we will be merging 4 7, and then we will be merging 5 8. Okay, so 4 and 7, if you notice, this is 7, they are having the same core item but different locats, right? So 4 and 7 will get merged. Okay, so this 4 and 7 will get merged. Similarly, 5 and 8 are also sharing the same thing. 5 and 8 will also get merged. Understood? So we will be merging it, and then we will be basically just shifting the 7th entry. Okay, so how to merge this 4 and 7? This 4 and 7 will get merged, right? So basically, if you merge it, then the new state. So wherever, see earlier also, wherever 3 was written, we need to write 3 6, because the state number, there is no state number called 3. Okay, I'm just writing state number as 3 6. So wherever 3 is written, you will be writing 3 6, right? I mean, state number, not the production number. This 3 is a production number, by the way. Okay, wherever 3 was written, you need to write 3 6. Okay, so let me just tell you that after merging, it will look like this. See, here it is 4, but after merging it will be 4 7. So it is 4 7 only, right? 4 7. You can definitely merge. It is not a separate 3 and 3 6. So both are same. So basically after merging, it will look like this. Okay. So you will be having 3 6 merged, 4 7 merged, and 5 8 merged. Okay. And wherever in the shift move, wherever 4 was written, I have written 4 7. Wherever 3 was written, I have written 3 6. Wherever 5 was written, I have written 5 8. Okay. So this is LALR parsing table. Okay. Is this understood to everyone? Okay. Now, let's see this example. Probably you will get to understand more, right? Let's see this example. Now, again, here we need to make an automaton. It will be a big automaton. So I'm just writing the automaton directly. Okay. So maybe I can just, draw few of the states, and then I will be writing directly. For example, we will be starting with this, and then we will say, okay, dot ba, then comma, because I'm writing this as because of this, then comma dollar, I mean first of this, right? Then b gives a, and then all the productions, let me write. and then different lines. Because I'm writing because of this b, right? Because of this b, so first of this is small a, right? Like this, there will be the first, and then we will be keep on doing it. So if we keep on doing it, you will be basically getting this big automaton. Okay, you will be getting this big automaton. So let me just remove some unnecessary things that I have here. Okay, just try it for the practice, that how to draw this LR1 automaton. And now the table is fine, right? Now you can make the table very easily. Why? It is easy to make table here because the follow or the locate is already available to you. Now in this if you make the table, you will be getting maybe I can even show you the table in case if you basically try it later on, right? Is this grammar LR1? Yes, because there is no conflict, right? There is no conflict in the table. So that's why this grammar is LR1 grammar. Okay. So table will look like this. Okay. Now can you merge? Can you merge the sum of the states? So I think this is different from everyone. I think every state is different from everyone. I mean, there is no even core items are same. Okay. So that is why this is the table. See, you can just quickly check if I'm correct or wrong. So I think every state is different from each other. Okay. So that is why this is a table for LR1 also, LR1 table. This is the table for LLR also. Why? Because there is no merging. The tables will, I mean, everything is same here. There is no merging. Because if you notice, every state is different from each other. Okay. Great. So this grammar is LR1 and LLR1 both. Similarly, let's just check this grammar. Okay. Let's just check this given grammar. Can you check whether this is LR1, LLR1 like that? So this grammar is given to us, and now they are saying so that this following grammar is LR1 but not LLR1. So this could be one interesting question. Just try it for few seconds probably. So basically, if you draw the automaton, then you will get to understand this. Okay. So let's just do it, right? So this is hash dash dot hash dollar, right? I mean, sorry, you will be having comma dollar. Okay, that is how you will be basically augmenting this grammar. And then s gives dot a dot bac dot b dot b a gives. Okay, sorry. So basically, you can easily maintain lockheads. I thought we can do it in one. Should we do it in one? Or maybe in different lines. Okay, let's just do it in different lines because it is a complicated parser. So it is better if we do it carefully. Okay, we are writing this because of this, so that's why comma dollar, comma dollar, comma dollar. Now because of this A, we need to write productions of A, and because of this B, we need to write productions of B. So basically, you can have more productions here. A gives dot D, and then since I'm writing because of this A, That is why first of whatever is remaining, which is small a. Now capital B dot D, which is small c. So basically this is your initial or the first state, right? I hope that is fine. Okay. Now let's just check it step by step. Now on small d, where you will go? I mean on capital A, I think this is easy. On small b is okay. Okay. Let's just see on small d. Okay. On a small d, you will be going to capital A gives d dot comma a, right? And what else? Okay, there is also b. B gives d dot comma c. This is one of the state. Is this fine? On a small b, where will you go? On a small b, you will be going to capital S gives b dot ac, right? And then b dot ba, which is dollar dollar, and then because of a, you will be writing all the productions of a. So where it will be dot d, and since the first of this is c, so dot d comma c, and then because of b, you will be writing all the productions of b also. Okay, so which will be dot all the productions of b, right? So dot d, but since you are writing because of this, so comma a. So I think this is where you will be going on small b. Okay, and where you will be going on small d from here? You will be going to a gives d dot comma c, b gives d dot comma a. Okay. So so basically, I mean, I'm not going to draw the whole automaton. You can draw it, but I just got two states, this and this, which are basically having the core item same, right? But lookouts are different. So actually, you need to merge these, right? You need to merge these. So when you merge, what's going to happen? Let's just see. Okay, when you merge, what's going to happen? So you actually need to merge these two. You will be getting one state where where you will be having, basically visually I'm just telling you will getting one state, the core items are same, which are d dot, right? And lookout items you will be merging actually, okay, for the core item. So basically here it is ac, here it is again ac. Okay, see, these are the things that were there in LR1, but now in LALR1 you will be having something like this. Okay, in LALR1 you will be having something like this. Is this fine? Okay, so so if you notice here that in LR1 there was no conflict. Basically you will say this is a reduce entry, this is also a reduce entry. You will be reducing this on small a, you will be reducing on small c. Okay, because you will be reducing what to whatever you will be reducing, it is already given in LR1. It is actually very simple. So there is no conflict here. There is no conflict here. Similarly, you will be reducing on a small c, you will be reducing on a small a. There is no conflict here also, right? But if you notice here, you will be reducing this on A and C, this also on A and C. So there is reduce conflict, or there is RR conflict here. There is RR conflict in LALR. RR conflict in LALR, right? So that is why this grammar is LR1. Actually, I have not drawn it, but if you drawn it fully, then you can prove this is LR1. But it is not LALR1. Why? Because if you merge it, then you will be getting a conflict here. Okay, there is RR conflict, which is called reduce conflict. You will be getting conflict here. Okay, so is this a little bit fine? Let me know. So basically in general, let me just tell you suppose you do not have, suppose any conflict in LR1. Suppose you do not have any conflict in LR1. Can you have the conflict in LLR1? Or in other words, what will happen then can we create, can we have, or can we introduce a conflict after merging? Suppose this is the question. In general, let's suppose if I want to answer this question. Okay. So for example, let's suppose there is no conflict to start with. Okay. Suppose there is a reduce move, but this reduce move is on a small a, and there is a shift move. This shift move is on a small b. Okay. I mean, on the shift move, for just to check the conflict, this look ahead move, look ahead symbol doesn't matter. So I'm not writing it because otherwise it will be confusing you. Okay. So I either I write A, B, C, D, doesn't matter because it is not determining the conflict, right? For the shift move, this will determine the conflict. For the reduce move, this will determine the conflict. Okay. So suppose this is one state. Okay. Now suppose there is another state which is like this. Okay. Where the core atoms are same. Core atoms are same. Again, this won't matter, so I'm not writing it. Okay. The core atoms are same. Now suppose there is no conflict. Okay. Which means that this particular reduce is not on B. Maybe it is on something else, right? Maybe it is on C. Okay. Let's suppose this reduce is on C. This reduce is on A. Suppose this reduce is on Y. Okay. These things doesn't matter. So let's suppose these are the two states that we have here. This is the LR1 states. LR1 states. Now what's going to happen after merging? You will be having A gives, I mean, this is the same thing, beta dot B. Okay, whatever this is. You will be having here A and C, right? You will be having A and C. So this is the merged state. Is there any conflict here? Is there any conflict? See, here this is AC. You will be reducing on AC. You are shifting on B, right? So again, there is no conflict here also. I'm not saying after merging there will always be a conflict. Okay. So again, there is no conflict here also. But let's just see the case that there can be the conflict after the merging. Okay. For example, actually it will not be SR conflict. So here, like I need to give the example of RR conflict only. But let's just let's just make sure that this is understood to you. That after merging there is no conflict, right? Is this understood? That if you merge it, there is no conflict. Okay. But now let me give you another example where if you merge it, there could be the conflict. Okay. For example, you have something like this. Okay. Here also the core atoms are same. Okay. But suppose this is reducing on A. There is no conflict here. Okay. There is no conflict here. I mean, this is on A and B. But let's suppose there is a conflict. I mean, there is no conflict here also. Okay. I mean, I'm just writing in the reverse. I'm writing BA. You will get to understand why. Okay. So there is no conflict to start with. So in LR1, there is no conflict. But when you merge it, are you getting the conflict? See, to start with, it is saying I will reduce. It is saying this state is saying I will reduce on A, I will reduce on B. I will reduce on B, I will reduce on A. I mean, they are saying okay, I'm reducing on different items, doesn't matter. But when you merge it, in that case, then you will say that this AB will get merged, right? I mean, this will be AB, right? And anyway, this is B. Even though this is, let's not worry about it. I mean, actually, it could be anything, but still there will be a conflict. Okay. See, this B and B is matching, right? In the sense that, like in this case, what will happen? In this case, you will say that since this B and B are merging, that is why there is a RR conflict. I mean, if this is A also, then there will be too many conflicts. See, this is a conflict on A and B both. This is a conflict on A and B both. How? You will be reducing here on A and B. You will be reducing this also on A and B. So on A and B, on two symbols, there is a conflict. See, earlier there was no conflict, but after merging, you got the conflict. Okay. So in LALR, you got the conflict. After merging, there could be a conflict only if or in other words, you can say that after merging, there can be only RR conflicts. I mean, you can introduce only RR conflicts. You cannot introduce SR conflicts. Okay. See, you cannot introduce SR conflicts. You can only introduce RR conflicts. Why? Because SR conflicts, if originally it is not there, right? Then since for this we don't care, right? So how will be you will be introducing? See, see, let me just tell you that you cannot introduce. Basically, first thing should be clear that once you merge, initially there is no conflict, but after merging there could be the conflict. Okay, there could be the conflict, or there could be no conflict, right? There could be no conflict. Now the thing that I'm trying to explain is that suppose you have these states, right? Now see, let's suppose this is shift move, this is reduce move. See, whatever is there, A, B, C, D, E, F, whatever is there, right? When you merge it, A, B, C, D, E, F, as long as there is no conflict here, which means, sorry, if it is not B, okay, as long as there is no conflict here, as long as this is not B, there is no conflict here, right? So this B is not matching with any of this. As long as there is no conflict, this B is not matching with any of this B should not match with any of this. So after merging, this B is not matching, right? See, this B should not match to any of this B should not match to any of this, to start with, if we don't want any conflict, right? To start with, if we don't want any conflict, so that's why I'm saying this B should not be matching with any of this. If that is the case, then after merging also, this B will not match with any of this, right? See, if you are saying initially there is no conflict, which means okay, this B is not matching with whatever you are writing here, A, X, Y, C, D. Okay, this B is not matching with this, right? So after merging, you will be getting alpha dot, these symbols will be increasing, right? That's the only difference, A, X, Y, C, D. But there also I'm making sure that this B is not matching, so it could be E, F something, right? So anyway, what I'm going to say here is that since this B was not matching here, similarly this B is not matching here also. Let's suppose this is E, F, G, H, whatever, right? And this is beta dot B. Since this B is not matching here, this B is not matching to here, that's why this B will not match to any of this. So that's why there cannot be SR conflict. I mean, if originally no SR conflict, so after merging also, no SR conflict. I mean, LALR cannot introduce it. But yes, LALR can introduce RR conflicts, in the sense that if there was no RR conflict earlier, after merging there could be RR conflict. Okay. So basically you can say, if LR1 has let's suppose has no SR conflict, if I say no SR conflict, then LALR1 also does not have any SR conflict. But if LR1 has no RR conflict, then LLR may or may not have RR conflict, right? Okay. So this is a summary, and based on this, there has been some PYQs. Okay. So basically let me directly jump to PYQs so that you can just, you know, solve them and understand them. Yes. So let's just see this. An LLR parser for the given column can have SR conflict if and only if and only if LR1 has SR conflict for this, right? It can have only if and only if LR1 has. Is this fine? Let me know. Okay. So there has been few PYQs like that. Let's just solve this question. What they're saying, which of the following statement related to the merging in two sets LLR1 is false? Okay. So see here, is the core item same? I think core item is same, right? So they can be merged. Okay, they can be merged. So just let me know that what is the answer you are getting here. They are saying false. Cannot be merged. This is false. Can be merged but will result in SR conflict. See, originally, let me just, this is a good question. Let me just zoom it out. Okay. So see, I hope that is visible to everyone. Okay. See, originally what is happening? There is, I mean, there is no conflict here because of this. This is not a shift move. So, okay, there is no reduce move, right? There is no even a reduce move. So let's not worry about it. Okay, there is no reduce move. So there is no chance of conflict. Can be merged, but will result no, false. There is no reduce move, right? Okay, that's very easy question. There is no reduce move here. Can you see any reduce move? Let me know. See here, if you notice, the dot is not at the end, right? So there is no reduce move. So you will say that okay, there is no conflict possible because either it is SR or RR, but there is no reduce move. So that's why it is also false. They cannot be merged since go-to on C will lead to two different states. They are saying they cannot be merged. Is this? See, this is the common core item. No, they can be merged. Okay, so that's why it is also false. Interestingly, all are false, right? Because the core items are same. So basically, D is the correct answer here because they can be merged. You can easily merge them. Okay, so in fact, if you merge them, what will be the, how will it look like? Let me just tell you. You can definitely merge them. There is no problem in merging. And if you merge them, they will look something like this. Okay, so I think that was done. Let's solve this question. Or maybe there are few questions. Actually, this is related to data flow analysis and all. So it requires some more knowledge of the, so this is compiler is divided into two parts. One is called, front end and back end. So this data flow analysis is the back end part, right? Okay, maybe you can solve these kind of questions. So basically, generally they ask easy questions only from parsing, right? So you might have noticed from the questions that we have already solved. So we have covered all of this four types of parsing, which is LR0, SLR1, LR1, and LLR1. And we have covered many questions. I hope you have understood, right? I hope you have understood all of this. If there is any doubt, you can definitely let me know. Actually, these topics are little big. So that's why it is really hard to cover in just one lecture. So you might have felt that okay, it was little bit of rush. It was just because it was marathon, right? So that is the only reason I had to basically rush it, because you have less time. Okay, but I have to make sure that you also solve easy conceptual nice questions. But if there is very complicated question, then obviously you can skip. Okay, because actually the complicated question can be asked only from handle, bible, prefix and all. Okay, so for those kind of questions you can skip if you have not studied that topic, right? But mostly we have covered. Okay, for most of the questions the concepts are covered. So I hope you like this video. Once this live streaming end, just put a comment. Okay, put a comment and let me know if you have liked this video. Okay, once this live streaming end. So that is all we needed to discuss in the parsing. Okay, just let me know your feedback. Okay, anything, just a one word is even enough. Okay, even if you put a one word, it will be enough. Okay, the one word like good, awesome, whatever. Okay, it will be enough for me. Thank you everyone.